Everyone, welcome to this first session of the day, which is, I think, quite stats-oriented. We're going to start our session with a first talk by Jan Schimmel on Julifying your data team.
Can you hear me? Yeah, okay. So, hey everyone, thank you for coming. I guess we can celebrate it with a bit of confetti. Filling it up. No, you can't see it. Well, I can, so I enjoy that. So this is my take on adoption of Julia in business, and some of it's less talked about benefits. Quick show of hands, though. How many of you work as a team? Okay. And how many of you actually use Julia programming language as the main language in the team? Well, that's a solid coverage. Well, I guess you're a JuliaCon after all. But I wonder that's probably not going to be like that on YouTube. So I'm trying to change that. So about me, my name is Jan Schimmel. I'm your friendly neighborhood data head, and I work on decision intelligence. I will explain that later at LexisNexis. My experience, well, it's a mixed bag, but the point here is that Julia would, this pitch about Julia adoption would apply to every single one of my roles that I had. I wish I learned it earlier. Quick disclaimer, this talk represents my personal views and not those of my employer. So what is decision intelligence? It's when you have that complex business problem that you own actually from start to finish. And solving it requires all these different disciplines. And you have 10 different data sets from different places, and you constantly have to align with your stakeholders. What is it that you're building and why? And also the work is really solved only when you've actually delivered the business value. So that's the sort of things me and my team do, and if this sounds familiar, well, you should definitely start using Julia for it. Well, why? I think Julia is the yet uncrowned queen of decision intelligence. It will allow you to learn faster, to build faster, and build better to ultimately advance your business. So if we break it down, the learn faster. In our type of work, the bottleneck is actually never the execution time. It's always the time to learn the new thing. Where with Julia, once you actually master one application, a lot of the learnings transfer to the next. So quick example here. Let's say you need to write a Bayesian model that, can you see my laser pointer? Oh, this projector is really lazy. Let's say you have to write this Bayesian model to evaluate your underpowered A/B test, right? It looks confusing, but actually, you already know distributions JL, so you know how to work with distributions. You know for loops. You know how to work with arrays. And you know how to write a function. So actually, you kind of know all the building blocks before you even started. Equally, let's take a backsolve operator. It has 150 different behaviors, right? But Julia picks automatically the right one based on the inputs you give it. Same with the in function. You just need to learn one name. That's it. So really the result is that with Julia's readability and reusability, both in terms of the packages, but also the function names, there is just so much less you have to learn. And it's actually easier because you can just look under the hood what's happening. Julia's real power is not just the language itself, though. It's the composability and the amazing tools we have. It's the flexibility where you can seamlessly jump from environment to environment and machine to machine and to cloud. And I just sent a piece of code that I wrote to my colleague, and it just works. That is magic if you come from Python. But perhaps the last mentioned one is the versatility, allowing you to write in the perfect coding style that you right now need. So you need a quick experiment full of one-liners, or perhaps you actually need an allocation-free production-grade code, that will run 1 billion times. Or maybe uniquely in Julia, you can actually pick any point on that continuum and then later change that. So the result really is an unbeatable time to build. And you can also build better. Other languages often force you to mold your problem into what the confines of the available packages are. But the package authors actually don't know your business, do they? Julia actually empowers you to focus on solving just your unique business problem. You just define the smallest piece of it. And Julia will just make sure it runs blazingly fast. I had a quick example here. You can build an insights recommender, which actually tells people the right thing to know, instead of looking at thousands of confusing dashboards, in just 200 lines of code. You just define the data containers, some basic interactions between those, and voila, your prototype is ready. So the result is really easy to understand and less error-prone code that is actually uniquely yours. So while short on time, I'm not going to delve deep into the business case. You can check out my thoughts on that. But in short, with modest learning time investment of roughly 1 to 2 months, you can actually cut down your project completion times in half. That's really return on investment worth considering. So we've talked about the why, but let's quickly run through the how. You really need to start with the right work, the right people, and the right mindset. The last one probably being the most important. So the right work, stick to the sweet spot of the decision intelligence I defined earlier. Don't try to build next GPT or update the monolithic platform, at least not first. People, the most important part. You really need a curious and brave team that's eager to learn. Not those stuck in 2017 using Panda 0.20 and constantly complaining. They will get 0 of the benefits I described. And I can't stress this point enough, because all those people that will use Julia will actually have to face new challenges, and they will actually need to change how they do things and change their mindsets to really get the benefits. And speaking of the mindsets, I think I saw roughly 3 big mindset shifts that were needed to really get value. First one was using environments properly. It's what is it, how to use it, compat bounds. Sorry, Pythonistas, but like you are heavily unprepared. The second one, embracing methods and types. It's one of the best features of Julia. So your team should really spend a day, create structs, methods, overload, break it. Get a lot of method errors, because half of their future errors will be method errors. So they really need to understand how it happens and why. And the last one, solve unit problems. Define your problems as small as it gets, because most of us have learned to always vectorize, and we were just confused about what we're really doing there. Julia will just make sure that the small problem that you defined will run fast, even in a for loop. For loops are okay. So you can build amazing things this way, and it will be faster and more correct. Few painful learnings. Don't try to convert everyone on day 1. Failed at that hard. And avoid premature optimizations. Remember, it's about building it first. Julia is just too much fun, so you can actually get easily carried away. So if you're interested, try Julia up and give it a shot, because, well, with the Julia Power team, your business won't be just keeping up with the times, like it will be blazing its own trail. Thank you.
Some degree able to come in with some credibility and get people in the team to convert. If you have people that are sort of not at the top level and want to promote Julia, do you have any suggestions for how to get the higher ups on board?
So the question was, if you're actually not at a higher level in the company and don't really decide what languages use, what would you do as, let's say, a junior contributor? Well, that's a hard one, and I've actually been asking that around JuliaCon this whole week. So the best things I've heard and also seen was do the same thing they did in Python or whatever else the other language is, and just do it better. Pick some of our biggest strengths. Pluto notebooks are incredible for their interactivity, and you can just show people the power of like gleaming insights, not waiting for Tableau to load for 10 minutes, right? Build these little things that don't cost you much effort, but really like a nail, just hit that focused point with maximum force and really sell the power of Julia ecosystem. Thank you.
Let's thank the speaker again. Next up is Nikola Surjanovic with his talk Pigeons.jl, distributed sampling from interactable distributions.
All right, hello everyone, and first of all, I'd just like to thank the speakers, for the organizers for having such a great conference. So in this talk, I'll present Pigeons, which is a new package that we are developing for distributed sampling from complex distributions, and it enables users to leverage distributed computation, use up to thousands of MPI communicating machines. I'll also describe some of our lessons learned on achieving what we call strong parallelism invariance, and so I'll describe that in detail and some lessons that might be of interest to the general Julia developer. Okay, so Pigeons, an overview of Pigeons. It is a Julia package for estimating high-dimensional integrals using sampling. And for instance, Paul Tita, who is here in the audience today, has been using the underlying algorithm in Pigeons called parallel tempering to use it to image black holes. Well, why is this, for example, imaging black holes, you can obtain a probability distribution on a set of images. Turns out that distribution is very high dimensional and has a complicated structure. And so something like Pigeons can be useful to solve this kind of problem. The underlying algorithm has been used in various areas of science, and just to list a few, and it has been used in quantum physics, nuclear physics, and so on, and we're excited to make it hopefully accessible to the general user. So Pigeons is designed to be easily distributed on up to thousands of MPI communicating machines, and we have seen, for example, an up to 500 times speedup using 1,000 machines. Communication is necessary for this algorithm, so we can't just run this completely independently on the 1,000 machines. They need to communicate with one another. And we also introduced new coding patterns, as I mentioned, to achieve something called strong parallelism invariance, where the output is identical irrespective of how many machines you use and how many threads per machine. So the problem that we're trying to solve, for instance, is you have some distribution, and x is distributed according to this distribution pi, and you want to estimate the mean of some function, say f of x. And this can be expressed as some kind of integral f of x times pi of x dx, or it can be a sum and so on. And more generally, we handle Lebesgue integrals, and Pigeons allows you to estimate these kinds of integrals and expectations. And it's based on a Monte Carlo algorithm where you obtain samples from this distribution and then you use those samples to estimate these quantities. It turns out that it's actually very easy to use Pigeons. So in the Julia package, you can simply call the Pigeons function, and first of all, you specify what your target distribution is. So in this case, our target is coming from Turing JL model. So it's very easy. You simply write a Turing model, and then you can wrap it around this Turing lock potential. We allow to interface with various probabilistic programming languages, such as Turing models, Stan models. If you're a Bayesian, Bayesians often use something called Stan. And custom probability densities, you can also just write your own function, say this is my density of the probability distribution. And also Comrade JL models, which are used for black hole imaging. And then there are also various other arguments that you can supply, such as the random seed and number of samples that you want to obtain. And I mentioned that it is easy to use pigeons with MPI communicating machines, so you can also just have an extra argument that says on equals MPI and how many MPI MPI communicating machines and number of threads per machine. And again, the output is actually identical no matter how many machines you use and threads per machine. So I keep mentioning this kind of strong parallelism invariance, and it is useful because for the purposes of reproducibility and also for debugging. So you can use pigeons on one machine with one or several threads per machine, or several machines with one or several threads per machine. So we guarantee this identical output and not just a kind of distributional equality or expected value, equality and expected value. The output is actually identical. And I'll highlight two things that might be of interest to the general Julia developer, not just people who are interested in sampling. One is that floating point arithmetic is not in general associative, and also the use of the threads macro in Julia. So these are, the first one in particular, floating point arithmetic, might be overlooked if you're first trying to implement something that satisfies this strong parallelism invariance. So adding x and then y and z is not the same as x and y and then z. And this has implications for distributed reduction. So whether, for example, suppose you try to sum floating point numbers, say 1 through 8, on 8 machines versus 2 machines. You can imagine going with one floating point number per machine, just as like a very simple example. You're just adding numbers. But the order of operations that might happen is you have machines 1 and 2 communicate, you get 3. And machines 3 and 4 communicate, you get 7, and so on. You proceed up this tree, and you get the answer 36. And the order of operations is indicated by that mathematical expression. But if you have 2 machines, machine 1 might sum 1 through 4 in its own order, and machine 2 will sum 5 through 8 in its own order, and then you get another answer. Again, it should be 36, right? But these answers might not be identical. And especially if you're doing something more complicated than addition, then the order actually matters in how you're doing these operations. So our solution is to do something different where we have each value that we need to perform an operation on to be a separate leaf node in this reduction tree, and then we assign the machines to the nodes of that tree to make sure that the operations occur in exactly the same order. So here, this is the same figure as before on the left side, but we're just using colors to indicate different machines. But now if we have 2 machines, so 2 colors, blue and red, we're doing the same order of operations, even though we just have 2 machines. And now the blue machine essentially is basically communicating with itself as if there were 8 machines present. So we have the same order of operations happening. And another thing that might be overlooked is the use of the threads macro. So this is just some behavior to be aware of. Maybe it is obvious to you, but if you consider this code where we print the number of threads available and then generate 10,000 random numbers and store them in a vector and print the last random number, if you're using the threads macro to go through this for loop, whether you use 8 threads or 1 thread, the output will be different. And so to kind of solve this problem specifically in our package, we created a new package on the side, splittable randoms JL, and it's a translation of the Java version of that, where you can create a master RNG and then split that to allow for pseudo-independent random number streams. And this can be useful for various applications. And in the call to ran, then you just specify the split RNG. And the output is the same no matter how many threads you use. So yeah, thank you for listening to this talk. And if you're interested, please visit our GitHub repository and hopefully forthcoming JCon paper, as well as if you're interested in distributed sampling or sampling algorithms in general, you think pigeons might be useful to you, please give us a star. It means a lot. And we're small enough now that we can actually take into consideration like any features that you want to see. So feel free to talk to me or email me if there's something that you want to see pigeons being capable of doing. Thank you very much.
Any questions?
You mentioned that you're using parallel tempering, right?
Yes.
Do we have diagnostics like are, for example, used in HMC or not? Do we have anything to know that I'm actually looking at?
Yeah, so it's actually, oh, sure. So the question was about diagnostic output for the algorithm, underlying algorithm that we're using parallel tempering. Yes, so we're actually using a fairly recent, like state-of-the-art algorithm called non-reversible parallel tempering, and that has been published recently, like 2 years ago. And we offer various diagnostic output. There's this thing called the restart rate that we offer as output, and so it indicates, so for those, just as a very quick description of parallel tempering, there is a reference distribution that we can sample from and obtain independent samples from, and we let those samples travel to a target which is more complicated. So we have this diagnostic that basically gives you an estimate of something like an effective sample size, except it is more conservative, which is good in the sense that it is more accurate for multimodal distributions, for instance. And so we have various diagnostic output. I didn't put them in these slides because it's a 10-minute talk, but yeah.
I guess the summation and floating points costs when doing distributed workloads. Is there any kind of like the way those values are distributed across machines? Is there any kind of locality thing going on there, or is there any kind of optimization to make sure that like these nodes are
Yeah, so the question was about how are we, in the case where, let's say you have 8 nodes, like 8 values that you want to perform an operation on, but maybe you don't have 8 machines, so you have 3 or something, so 3 doesn't, 3 times anything doesn't, like it doesn't go into 8, right? So like how are you assigning the machines? So it's done in a way so that basically the goal is still to have, you only need to do, like you can, yeah, basically optimize this so that it's, you're performing as many in parallel as possible so that you're not waiting. Yeah, I won't go into, I guess, details, but yeah, this is taken into consideration. Yeah. Okay. Okay, thank you.
We now have José Storopoli with his talk, Writing a Julia Data Science Book Like a Software Engineer.
Okay, so hello everyone. So what is the Julia Data Science book? So let me just briefly show you here, and then I can start my talk. So this is the book. It is pretty much available in PDF and HTML. And you can check it out at juliadatascience.io. So the book was written by me, Rick, and Lázaro. And the whole idea was not only to write a book, but do it in a different way that the book remains up to date with Julia and other issues. So it is a free open source and open access book. It has a Creative Commons license. It teaches not only Julia, but also data frames meta, Maki, and algebra of graphics. And our target audience are mostly PhD students, but anyone is welcome as an audience for the book. It is mainly in English, but thanks to these amazing people, it was translated by volunteers to Chinese and Portuguese translations, and we are also accepting and looking for other languages for translations as well, so feel free to reach us. And how did it happen? So we wanted to do a book, but first of all, we had to do some yak shaving, and there is like a small footnote for those who don't know this expression. It's very popular in software development. And first, we had to create a Julia package to do to like present a book, and that's where books.jl, which is originally from Rick. It's a package that uses all of those tools, Pandoc, Crossref, Tectonic, that generates books and other HTML, PDF or LaTeX documents. And since it uses a Pandoc under the hood, I think it also supports other types of documents. And what it does does the proper embeddings of a lot of things like data frames as tables, HTML tables or LaTeX tables, and plots as very good plots in either HTML or PDF format. So we had not only to develop this, Rick did mostly of the heavy lifting. I was also finding bugs and annoying him all the time. So once we had books.jl that was ready to do this, we wanted the book to be built, to build itself in a CI/CD pipeline. And the book, it automatically builds itself and deploys both the HTML and the PDF versions to the Julia Data Science website and also to the GitHub repo as artifacts. This is also programmed to run chronologically, so we know if data frame is 1.7 breaks something, we know that we can fix this so the books remains up to date. We had some challenges with Maki because it's a non-display runner in GitHub, but Maki documentations have good examples how to circumvent that. And also we had some challenges with integrating this with the Chinese and Portuguese translations because all of those need to be in the same CI/CD pipeline. The good thing is that the content was created and it's being edited as PRs. So all of the discussions, all of the ways that we are presenting new concepts to users, it's pretty much like an ongoing discussions between the co-authors, but also the community. So you are all invited to participate, open issues, or discuss in the PRs, and also contributed. We have not only us three doing the authoring, but we had some contributions for other people. So this is really nice. All of the PRs, you can pretty much go in the history backlog and see what were the decisions that we took and why we took those decisions. So it's open, it's transparent. We also use, I mainly use the project management tools in GitHub to track our status. So for the first edition, for the second edition, and we are still kind of using this. So it's a nice tool. You can check also in GitHub how to do this. And that's it. Please check us out at juliadatascience.io. Share the book, it's free, both the HTML and PDF versions. And if you find something, a typo or something that you think needs more polishing, feel free to either open an issue or a PR. Thank you. And questions?
Hey, thank you, Jose. It's a fantastic project, Red Book. Tell us a little bit more about what platform did you use to write the book? Was it like Weave.jl or like a JMP or a Word document? And what did you exactly do to write it?
Okay, so the question was what kind of platform or file types that we use to write the book. So books.jl uses Markdown files with a certain kinds of snippets. So we mostly use Markdown files, so it's highly accessible. And there's like ways for you to do fancy code blocks that books.jl will run, evaluate that code block, and then it will bring the result into the book, and you can also do post-processing inside that code block.
So can anyone use that book.jl to write their own books?
Yes, not only books, but also reports, theses, papers, and everything else.
Bibliography is handled.
Yeah, how the bibliography is handled. It is handled. I think that might be a citations.bib, so a bibtext citation. I think that is very okay because I don't have traumas or issues with the bibliographies from what I remember from the writing of the book. So I think it works pretty okay. because we do have some citations and it was pretty straightforward to incorporate them. Just one thing that I forgot, even this book cover, it was done everything in Maki. So even the book cover, it's like Maki code that you can pretty much hack into it and do all of those fancy plots here as well.
Okay.
Thank you.
We don't have any more questions. Let's thank again all the speakers. Yeah. On to the next session.
Hello, is this audible? Okay. Okay. Hi, I'm Ayush. I'm representing XKDR Forum. Is the audio okay? Should I be louder? Okay, is this better? Yeah. So I'm representing XKDR Forum. We are an economics research think tank in India. We were users of R for the longest time, and then we saw Turing.jl, and then we thought we must shift to Julia. So then we shifted to Julia. So we shifted around 2020 August. But we found that a lot of the basic things were lacking. So we found, for instance, in lowest.jl, you could not put more predictors. And in GLM, we found you could not do QRD composition. So we started fiddling with those things. We started doing some PRs, and then we got a project from the Julia lab to develop these things. So we are developing 4 packages, which are widely used in R. And we're also doing PRs and improvements in terms of issues to existing Julia packages, such as GLM, hypothesis tests, distributions, anything under the hood. So today there are 4 talks, one by myself on survey. So survey is a widely used R package. Then there is one more by Bogomil on GLM. So he's not in our team, but we've been collaborating a lot together on GLM and various other things. So the other live talk today is by Bogomil, and then there are 2 recorded talks. There's one more on GLM, because we think in statistics, it's one of the most important things. So there's one more on GLM, and there is one more on regression, but this one is more on the Bayesian side. So we're building a package like Zelig, which is in R, and then we're using Turing, GLM, and other things as the dependencies. So I'll start with survey.jl, and then we'll move to Bogomil's talk. His talk is on using GLM in econometrics. So he took the standard book, Jeffrey Wooldridge book, and then he basically solved that using glm.jl, and then he discusses the things that are lacking and that are there and what can be improved. Right? One more thing that I want to add. Yeah, one more thing that I want to add, that we are also trying to promote Julia in India. We are taking a lot of students as interns and trying to mentor them. We are also doing meetups, so we're also in that process. So other than just the packages, we're also thinking just generally about Julia and how to have it more in India. sorry, I want to mirror this so that I can see it here as well. Yeah. So I'll just briefly describe the problem statement. So suppose you want the average height of Americans. You can go and measure everyone's height and then take the average. But that's obviously not feasible. So you take a small sample. You take 100 people at random or something and then take the average. But that number won't be perfect. It would be an estimate. And that estimate would have a margin of error. So this package is about finding out that margin of error. Surveys can be a little more complicated because if you take 100 people at random in America, then you'd be hopping from Alaska to Florida and so on. So that's not going to be cost effective. So what you end up doing is that you select some places at random and then you go there. And then within those places, you select some people at random. So there are these complications. And this package is about, given that these complications, how do you compute the margin of error? We're going to use variance, standard error, margin of error interchangeably, confidence interval. They're not the same thing, but they are calculated from one another. So you need functions and algorithms that are specifically made for surveys to deal with these complications. These functionality are there in other languages such as R, Stata, SAS, and so on. We've been using the package in R by Professor Thomas Lumley, and it's been, so he's part of the R core team, and it's been developed for the past 2 decades. So it's a stable package, and we've been using that for the past 5 years. Now, surveys are becoming larger because you can do telephone surveys, you can take internet surveys, so so you need a more efficient computing framework, and that's why we thought of this being a good place to, so Julia would have a good role in this, I think. Yeah, so we are committed to the development of the package because we are using it ourselves, right? We are analyzing household data for our economics research, and that means that we will be developing this package in the long run. So a lot of Julia packages, I feel they start and then they, it's like a pet project for somebody, and then they, it doesn't end up going. And we feel if there is some application that the developer has, then it's more likely that the package would keep developing. So that's why we've chosen to put our resources in survey.jl, while there are so many other options that we could have started with. But this is something that we are using. And yeah, that's why we think the development will keep going on. The second thing is that we have been long users of the R package, so we know the ins and outs. And the way we are developing is we are testing everything against the R package. So if you do a PR and the answers don't match with R, then we don't accept that PR. So you can assume that all the answers are correct because they're all, if the R package is correct, and the R itself was tested against data and so on. So if somebody made a mistake like 30 years ago, then we will have the same thing. But otherwise, you can assume that the stats is correct because it's been matched by other systems. Okay, so we want the data to be in a data frame. And then all the underlying operations that we have, like group by and combine, they all use the data frames API. So we want the underlying system to be data frames. So the general workflow is that you have some SQL server, and then you pass that into a data frame using DB interface. And then from there, you from there you use the survey package. Alternatively, you can have a CSV file, and then we were discussing for the past few days about Arrow and other systems. So for playing around, there are some toy examples with the package. So you can use something like load data Nahans, and then that would load the Nahans data, which is small survey data included with the package. These are used for tests and also for documentation. You can test out the documentation using these data sets. Okay. So with the data set, if you pass information about clustering and stratification, weights, the complexities of surveys that I had earlier mentioned, then you make a survey design, and then you use all the estimators on that design. So there are certain features, so the data is there, and then there's some other information that you need to give. And then from there, you construct a survey design. So here's an example. Suppose you have a simple random sample. So something like I described earlier, if you selected 100 people in America at random. So there you just have that data. So we have a sample data set for a simple random sample. It's called API SRS, and then you can make a survey design from there. Now suppose you have a stratified sample. So a stratification is, you can think of it as if you were to sample each state of America differently, so then your state would be the stratification or the strata, and then you can pass that information in the survey design constructor. Similarly with clustering, if you have clusters, so I had given the example that you pick some cities at random, so then those cities are your clusters. Then you can pass that information. Then there are multi-stage. I won't go much into this because this has not been implemented. So you can have the constructor, but all the algorithms approximated to just single stage. And then you can have both stratification and clustering, so you can pass both that information. Here's a real-world example where there's both stratification and clustering. And this is actually the data we use at XKDR. So yeah, we use DB interface, and then we pass that to a data frame. And then from there, we make a survey design. Okay, so I also want to use this opportunity to discuss the internals. Internally, if there's only one constructor, so if you don't pass strata, then it'll make a strata column. If you don't pass clusters, then it'll make a clusters column. And this just makes our life easier from a developer's perspective, that we just have some functions that work on everything instead of separate functions for each kind of case. So you can do various estimations. So for example, I told you about the average height of people. So that's a mean, and then you can do median, total, quantile, and so on. You can also do multivariate estimations such as ratio, regression, and then so on. There's also domain estimation. So sometimes you may want, let's say, the average height by a state. So that by is a domain. So you often want that, and that really complicates things often. So suppose you have a survey design, then you just call your estimator. In this case, it's just mean and quantile. So you just tell your column, and then your survey design, it gives you the mean. In this case, it automatically computes the weighted mean and weighted quantile. You can also do GLM, so you pass your design, and then you pass your formula, and you can do ratio also, but these are currently being implemented. I talked about domain estimation, so you can have a domain. In this case, I just did it with S-type, and then for each S-type, you'll have the mean. Now coming to the heart of the problem, the variance estimation, or the estimation of the margin of error. So many packages such as GLM give you the standard error, but they don't take into account the complexities of the survey design. And that's what this package is about. This is what the R package, the Stata, and then so on are about, that you use the sampling design in the calculation of the standard error. And there are two ways of doing this. So one is called Taylor linearization. We have not implemented this in the package. The other is resampling. So you simulate your survey using the survey design. And then for each of the simulation, you find out your estimator. And then from there, you find out the variance. And this is where Julia is a lot faster than R. We found that for most of these simulation techniques, it's about 10 times faster. You can think of it as, for the same amount of time, you can do 10 times more samples of your simulation. There are some standard techniques of doing this simulation. So one is bootstrapping. This is not deterministic, but it's the best approach. Then you have jackknife, which is deterministic, but it's a bit biased, and then some other ones that we haven't implemented. So you can use this function called boot weights to create a replicate design, and then it uses this formula for weights to create the replicate design. But notice that it added additional columns in your data frame. So if you made 1,000 replicates, then it adds 1,000 columns in your data frame, and it modifies your original data frame. Using these columns, then it computes the variance using a formula. So if you pass the replicate design instead of the survey design, and in addition to the estimate, it also gives the standard error. Similarly, you can do it with jackknife. You pass your survey design, and then it makes a replicate design of type jackknife, and then it can calculate the variance using this formula. So if you pass a replicate design instead of a survey design, then it gives you the standard error in addition to the point estimate. Internally, it's not just for mean and total and some simple functions. You can do it for any function. So there is a variance function, and you can pass any kind of function into that, and it would compute the variance for that estimator. This is the same way it's been done in R also. So just about what we are trying to do from here and in the future, we'll do all the, we'll port everything from the R survey package, and then we'll try to integrate the cutting edge features like Turing. So for instance, you have prior for your, for the mean or the parameter of the mean. So we want to be able to integrate that with survey. Right now, the way to do it is you do bootstrap on top of MCMC, but that's too costly. So we're trying to find a trick, but even that is much faster in Julia. MCMC is faster and bootstrap is faster. So compared to R, you'll be a lot faster if you use this. So finally, there have been 3 main contributors. There are 2 Google Summer of Code students that have worked on this. There have been numerous volunteers who have done PRs. So there are many people who I don't know, who have just done PRs to the package. And there are some people who we've had good discussions with. And yeah, we acknowledge the support of MIT and Julia Lab for financially supporting the project. That's all. Okay, any questions regarding this or XKDR or what we're trying to do, anything? Yeah.
So, this is fantastic. So you considered the Lumley's survey package?
Yeah.
Now, is there a procedure where we can use factor analysis in survey JL?
Not right now, but the idea is something like this. Yeah. Yeah.
So what function does that in survey JL?
So right now, the Lumley's package is just like a base package for survey, and then there are like 50 packages built on top of that. So I imagine one of those packages would be doing that. I'm not very familiar with factor analysis. So, but the core functionality is what we're trying to do right now. And then later on, we can do all the other packages built on top of Lumley's survey. So for example, like inequality packages built on top of survey, and there are 50 other packages. But at the core, this is what the package is. Just you pass any arbitrary function, and then it gives you the variance for that.
So at the moment, it does weighted sampling
Yeah.
for the survey.
Yeah. Yeah.
Very naive question. Could you just briefly go over the difference between clusters and strata again?
Yeah. So strata, so suppose you sample 100 people in America, then it's possible that you underrepresent certain regions, right? Let's say by chance you don't get anyone in Florida, right? So just to avoid that, you can divide your divide your population into groups, so you can have state-wise divisions, and then for each of for each of those states, you do sampling independently. So you can out of time fix that. I'll pick 10 people from Florida, right? So you're sure that you're not undersampling it. So that's stratification. But so these are independent. So then Florida is independent of, let's say, California, right? Clustering is, suppose we have these groups, suppose we have these states, and then I pick some states at random, and then I sample all the people in the states. So actually a better example of clustering would be if, let's say, you were testing light bulbs, right? So you have you want to find the defect rates of light bulbs, and then your light bulbs are in boxes. So if you do a random sample, so if you just had the list of light bulbs and if you just did a random sample, then you would end up opening a lot of boxes, right? So what you do is you select some boxes at random, and then if you've opened a box, then you might as well sample all the bulbs, right? So that's the idea of clustering, that once you go in a place, then you sample all the entities in it, because once you're in a state or once you've opened a box of bulbs, then you might as well take all the samples. So that's the difference. Okay, over to you, Bogumin.
Let's see. Okay, so first of all, thank you very much for inviting me to join this session. So I'm not a core contributor to Julia statistics, but I work a bit with it. I mostly, as you probably know, work with Julia data, but still as an instructor at academia, I was interested in a simple question. So are we ready to tell people who teach introductory econometrics just, switch to Julia and you can make a complete course on introductory econometrics with Julia? And today's talk, the objective is to share my experience, if it's doable or not, and what problems I encountered. So in general, to teach introductory econometrics, you need 3 components to make a complete course. So the first is you need some data pre- and post-processing tools like data frames.jl. because you need to get the data and maybe to save the results, etc. The second, you need the tools to do the actual data modeling. And the last thing you need is some plotting functionality, because in general, especially in econometrics, my experience is that seeing your data, like being able to visualize residuals, etc., is really crucial. So when I faced myself with this question, so my immediate answer was the following. So I'm pretty sure that with data pre- and post-processing, we put really a lot of effort to just be able to answer yes, this is already pretty feature complete. There shouldn't be any significant barriers for using Julia to getting the data, pre-processing the data, etc. Especially what we all heard in the data symposium, and we also will have a discussion of this today, with TS frames. So if you have time series data, you have a package for this, etc. For plotting, I'm pretty convinced that also we have everything we need. So the package ecosystem around plotting is, I think, very mature and super nice. And I really enjoy it. But for data modeling, I said, we really need to check. So I feel that yes, but maybe there are some obstacles that would stop people from start using Julia in those introductory econometric courses. So, I thought that in order to answer this question, it's good to take some process-oriented approach, so that it's not just my opinion, but I check it on something that is real. So I said, okay, let's pick some standard introductory econometrics textbooks and just reproduce it. So can we do everything in this book? If we can, then we say, well, we are ready. If not, then we will know what we are missing. So after thinking a bit, so I decided to pick the Introductory Econometrics, a Modern Approach by Jeffrey M. Wooldridge, because it's, at least I believe, the most standard book used in graduate courses all around the world for introductory econometrics. And I decided to focus on part one, which is regression analysis with cross-sectional data. So this is chapters 1 to 9 in this book. What I have skipped is time series, panel data, instrumental variables, simultaneous equation models, so all the things that are in further parts of this book. The reason is that, at least my experience is at my university, one semester introductory econometrics actually covers only part one. So of course you have time series courses, etc., but those are usually separate courses for this. Similarly, probably you don't teach instrumental variables in the introductory econometric course. So so of course those are all things that are needed in econometrics, but at least I thought we do not want to say that everything that is covered there really needs to be there to start teaching econometrics. And when I thought about those requirements, the answer was, well, given part one of the book, GLM-JL should cover all of it. So, of course, if it's time series or panel data, probably different packages would be needed, but I would expect that for introductory econometrics, you should be able to tell your students there is one package, just use it, and you will have it end-to-end. So what I went out to test is, okay, let's try reproduce everything in this book using GLM-JL. So this is what I did this spring. So what I did, I reproduced all examples in the book, all problems in the book, and all computer problems in the book. So if you know this book, examples is what's in the main text. So what Wooldridge explains, then problems are problems that show results of estimation, but ask you questions, but I reproduced also, the tables that he gives, and computer problems, well, are the tasks to really, for students to do something, and I also reproduced all of them the same way. And where possible, I cross-checked the results I got against what the book produced, and like I didn't ship out anything in case it wasn't consistent. So everything I will say is that, so the first comment is, I was able to get exactly the same thing as Wooldridge really presents. So this is like the first level of check. Additionally, while doing it, I create not a package, but a repository. Okay, so how now to switch to it? So I created a repository that contains everything I did. So it's not a package, it's just a repository. For each chapter from 1 to 9, there is a file with codes for this chapter, like, let's start with chapter 1. So everything there. It's not always, as you can see, it's not always just doing a regression. Sometimes Wooldridge says, okay, let's filter the data, let's compute some simple statistics. So I also reproduced all this. And here you can see that for all the problems, it's annotated which problem from which chapter is what kind of model. So here we have, standard GLM formula to do some estimation and, some post-statistics, etc. There is one extra file, init example, and those are the things that I needed to define myself, and also the extra packages that needed to be loaded. But I will comment on it in a second. So, now let us discuss this point. So I already told you that I reproduced everything. So if someone wants to teach introductory econometrics using Wooldridge with Julia, like a complete set of codes is there on GitHub, but what was missing? So first thing is that in GLM-JL, Cholesky decomposition is used for estimation, and I guess that the reason for it is that it's more efficient than QR decomposition, but at the same time it has lower numerical accuracy. And actually in 2 problems in the book, this caused the estimation to fail. So I propose in the codes the workarounds, so how to get the results still having the Cholesky decomposition, but this issue is fixed in 2.0 release, and this is thanks to XKDR actually contributions, where in GLM 2.0 you will have an option to choose which numerical method is used to estimate your models, and if you accept to have a bit slower estimation but with higher numerical precision, you can switch between 2 modes. So still the fast mode is the default, but you have a slower mode that is more accurate. Also, while working on this, and this is maybe something that will be useful for GLM-JL users, and I hope there are some in the room. Actually, there is one more difference. So you are probably aware that what GLM-JL automatically does, it automatically does multicollinearity detection. And if you have multicollinearity, you can opt in for dropping multicollinear variables automatically. And in general, this is nice. And here is also something that is a bit different, but I think it's good that we have both options. So if you use the default Cholesky decomposition, near multicollinearity will lead to dropping variables. So if you have two variables that are super highly correlated, but are actually not like one is scaled as the other, with Cholesky decomposition, if the relationship is really close, you will get it dropped. With the new option in 2.0 release, near multicollinearity is not treated as multicollinearity. So again, depending on what you need, either you want to drop, usually you want to drop super correlated things, but sometimes you want to keep them even for like diagnostic reasons, and this option will be added. Oh, it's already implemented and it's on master, but it's just not released because, as you can see, this is 2.0 release, so really a big big release because there are some breaking changes between the releases. So this is like maybe not the biggest problem, but this was a problematic at the core level because this meant that some things that you could estimate easily in R, you switch to Julia and you just got a different result. Then there was another limitation that is currently in the works, and hopefully soon it should get merged. So JL does not have as complete support for weights as R. But again, this is something that is a PR in the works, and hopefully soon it will get merged. But again, in the codes I have shared, wherever weighting was required by Wooldridge, I implemented it like manually, and it works. So again, it was not a blocker that you cannot use it, but like there is one extra function that needed to be defined to get proper standard errors of estimates under different weights. And I implemented it, but again, there is a PR to GLM-JL where all kinds of weights are added. So support for analytic weights, inverse weights, etc. All the weights soon should be handled like out of the box. The third bullet is something that I think was the most, maybe not problematic, but the biggest thing. So GLM-JL does not provide robust standard errors when you have heteroscedasticity in the error. And this is something I had to implement. Similarly, I couldn't find like a reference implementation for LM test and for Wald test. And as, you know, for example, Wald test is really often needed if you have some more complex relationship between variables that you want to test hypothesis against, like if coefficient 1 plus 2 plus 3 are equal 0. So this is something that was missing, and I also implemented it. And the one thing that Wooldridge uses that is not covered again in GLM-JL was least absolute deviation estimator. So GLM-JL just provides a standard estimation, but not least absolute deviations. But this was relatively easy to add. And the last thing is studentized residuals. Again, this is something that sometimes is requested by users, and Wooldridge uses it, but again, I couldn't find it implemented. So all those things are implemented in this extra file that I have shown you and can be used. So what are the conclusions? So the first thing is that, you know, I have tested the package, and everything that is in Wooldridge I was able to get. And also, there is a complete GitHub repository for anyone teaching introductory econometrics that you can just use those codes and give this course using Julia. Still, some features were missing, and I hope that, you know, we have this mini symposium so we could discuss which things should be really added to the package and which things do not need to be added. For example, I think that those robust standard errors or studentized residuals are something we should have in the package. maybe least absolute deviation estimator is not something that is a core part of GLM framework, so this could be skipped. And again, while it is not there, everything that is needed to run those basic econometrics things and is missing in GLM is there available on GitHub. So if you are missing it, you can use it. So this is like a short summary of the status of this. So I really want and expect to convince econometrics teachers at my university to switch to Julia. Now they have, everything they need, so they don't have even to write one line of code. They can just copy paste the repository and follow the standard textbook. And again, if you have some questions, I invite you to ask. And if you have some comments or thoughts about which things should be added or how they should be added to GLM, JL, or in general, what should be the curation of the future development of GLM, JL, because I think it's like a really super important package that is workhorse for introductory econometrics. I think it would be good to have a bit of discussion around it. So thank you very much, and I hope someone will find this repository useful. The question was why I don't use notebooks. The answer is because I don't use notebooks. So sorry, but so in short, and I think many people in the community prefer terminal to notebooks because Julia terminal is like way better than notebooks. So I normally use terminal, and that's why I create the GL file. But of course, to convert them to notebooks, it should be pretty easy. Actually, I have not formatted it, but I think that they could be even automatically converted to notebooks using this literate package, because the format I have used, I have comments, and those comments literate will recognize them as text and just can automatically change them to notebooks.
You said that the Cholesky decomposition was failing. So why was it failing?
It was so I can give a general answer, and then I can give you a precise answer in the context of GLM-JL. So the general answer is that Cholesky is less numerically stable than QR decomposition, and this is like the short answer. So wherever you have an ill-conditioned matrix, you will get a problem with Cholesky and less problem with QR. So of course you can cook up a matrix for which also QR will have problem, but it is much rarer. And now the question is, okay, but in what cases do you actually find this problem in econometrics? Because what I have said is like an abstract comment. But when do you encounter this problem in econometrics? And the answer is you encounter this problem in econometrics where you are adding quadratic terms to your models. Why? Because if you are adding quadratic terms, like here, sales and sales squared, because the range of squares was quite high, actually sales and sales squared were super highly correlated. And because of the numeric precision, Cholesky failed. And the simple solution is like divided by 1,000, for example. So then you have a lower range of those values, and if you have lower range of the values, you know, the precision relative to the constant term, because of course here we don't see it, but we have a column of ones. So when I not divide it by 1,000, I have like billions somewhere. And those billions relative to 1 are a completely order of magnitude different, and that's why you get problem with numerical precision. When I rescale it, then those squared values are more close to the constant term column, and Cholesky works. So, so this is like a GLM-JL related answer where you have problems. You might have problems with Cholesky decomposition if you have quadratic terms in your models, and the value and the variable that is in quadratic, uses quadratic terms, has a super high range. Like here it was sales, so I think it was like millions or billions, and if you square it, it's like a super high value. No, so what you have to do now is, as you can see in the code here, you just need to rescale it. But with GLM-JL 2.0, you will say that instead of using Cholesky, use QR decomposition, and then it will work, like without this workaround. The nice thing about the stats models package that underlies GLM-JL is that, as you can see, writing those formulas that I actually do not want a variable, but a variable divided by 1,000 is super nice. So this is the good thing, I think, about GLM-JL, because in R you would need to put this capital I everywhere. Well, maybe not that much typing, but still, you know, having a formula without those I annotations is cleaner. So, you know, the fix for now is easy, but hopefully, again, it's merged, so it's not like if I switched from a current release to master, I could just use QR decomposition, but we hopefully will soon get a 2.0 release, and then we won't need this rescaling. Sorry.
You made a really good point about the sort of the difficult judgment calls that GLM.jl, right? Where like GLM.jl is used sort of by a lot of different contexts, right? And so there's always a temptation to like, well, you know, in this field, this is a very common thing that everybody wants to do, so of course it should be included in GLM.jl. But it's like GLM.jl is being used in like probably dozens of different domain applications, and every single domain has a different idea about what is like the thing that needs to be in the package, right? So there's a lot of tension in this sort of like deciding how to do that, and also that, like, you know, maintainer bandwidth is super limited, and every time you put something into the package, then like to make any change in the package, you then have to update that other thing to be consistent with whatever other changes were made to the package. So it makes like the development and the maintenance a lot harder versus like having, and then of course there's a downside to having a million tiny packages that are like GLM for X or GLM for Y, right? So, but yeah, it's really tricky for something that's like so deep in the stack of so many different fields, right? Of what goes into this package.
Yeah. So actually, so I agree, and that's why I have commented, because the other thing I could do is like open issue for every this missing feature and just try pushing for including it. But this was exactly the thing that I thought that it's actually, maybe a wider comment. As a data frames JL maintainer, I know that the hardest decision is to say no. Someone will be disappointed, but if you don't start saying no, you, in the long run, will be in a huge trouble because you have an unmaintainable package. So this is kind of your comment, and I like fully agree and understand. And so, for example, this least absolute deviation probably should not go into GLM-JL. There are some things that I think should go, like robust standard errors and weights. Those are things that I probably think most of people would need. Where should tests go? It's not that clear because we have hypothesis test JL, but they are not aware of GLM, and those tests are like GLM specific.
We were putting that together, you know,
Yeah,
3 years ago, right?
yeah, actually, yeah, this makes sense. So like if you say, okay, loads, hypothesis tests, and then you say, okay, so I can add several more tests that are in combination. Yeah, makes sense.
Did you compare the answers with R or something else?
Yeah, so as I have said, all the answers that are given in Wooldridge, I have checked them to be identical. So that's why this is this, because, you know, those are, you know, complaints or gripes, as we say it in Julia. But, you know, the major thing is, well, it passed the field test of doing exactly the same thing as is expected. I think that Wooldridge was originally implemented in Stata. I have not checked it, but I'm pretty sure that it was Stata, so we produce the same results as Stata. But yes, this was like, because, you know, you can have some missing feature, but the bigger problem is if you start getting results that are incorrect. So, you know, I have done probably so for sure several hundred regressions. I don't know if it was 500 or 200 or 700, but it was several hundred different problems. And I really checked that in all of them we get the same. And as you can see, some of them were kind of hard with this multicollinearity. And, you know, we had 2 problems. So this is something that your colleague has contributed and solved this problem. So apart from this is like, maybe I'm not the person to say that if I say it's good, but it was like really field tested against many, many data sets, and it produces consistent results with what the textbooks showed.
So now we'll go deeper into your question of why Cholsky was failing and why are we choosing to do QR. So the next talk is by my colleague Mosam. He's done, I think, 6 PRs into GLM.jl. The significant ones, I think, are the multicollinearity one and the QR decomposition one. So the QR one just got merged. It took almost a year. And Bogumil was actually the main, he helped us as much as we did in that. So he basically reviewed our changes every day and got back to us. It was a very long process. Yeah, and maybe Bogumil might be better at answering your questions on this than me. So we have 1 more hour after this, right? Yeah. I think we have 2 more hours, but we'll need only 1, I think.
Yeah, but like here it's like a continuous session. So at
12:30 we'll.
12 we have a break, right?
Yeah. I don't think we'll need the session actually after that. We'll discuss because.
Or maybe we might wait, because you say that to wait like 5 minutes in the schedule, right?
No, I was just wondering. I'm not supposed to chair.
Yeah, it's probably the question to you. Do you want to wait till 1:30 to start this talk, or do you want to start it now?
I think we can just do it now. Yeah. Is this okay, or there's a...
We have added a new keyword argument called method in the lm and glm function in glm.jl module. The method argument takes only two symbols, Cholesky and QR. The method argument controls which matrix factorization method to use. If method equals to Cholesky, which is the default one, then Cholesky decomposition method will be used. If method equals to QR, then QR decomposition method will be used. In this presentation, we'll empirically explore the impact of these two matrix decomposition methods on estimating parameters in linear models in terms of accuracy and performance. As we know, the efficiency of estimating regression parameters depends on how efficiently we can compute the inverse of the matrix. It becomes more difficult computing a matrix inverse accurately for an ill-conditioned matrix. The condition number provides insight into the numerical stability of solving linear systems involving some matrix A. A high condition number indicates that the matrix is ill-conditioned, meaning that small changes in the responses can lead to significant changes in the solution. For an ill-conditioned matrix, solving linear system may lead to numerical instability, loss of accuracy, and amplification of errors. Whenever the condition number above a limit or higher may indicate severe ill conditioning, which could raise significant challenges in solving linear systems accurately. In such cases, using more stable numerical methods or considering matrix preconditioning techniques becomes necessary to obtain reliable results. Matrix decomposition or matrix factorization is the process of breaking down a matrix into a product of simple and more structured matrices. These decompositions are valuable in various areas of mathematics, engineering, and data analysis, as they simplify computation, reveal underlying patterns, and enable efficient solving of complex problems. QR decomposition factorizes a matrix A into the product of an orthogonal matrix Q and an upper triangular matrix R. Cholesky decomposition is applicable to symmetric positive definite matrices. It factors a matrix A into the product of a lower triangular matrix L and its transpose. Now let's start with playing with Julia JLM with two different decomposition methods, Cholesky decomposition and the QR decomposition. First, let's include the required packages. Then let's fix some random shifts so that we can reproduce the results. Now create a random matrix of size 10 cross 2 and let's fix some beta value 5 and 10. We can see that condition number of the random matrix is 3.13. It is not a very big condition number. So let's generate some response vector. Okay. So what we have done, we have created a random design matrix of size 10 cross 2. That means it has 10 observations and 2 covariates or 2 predictors. And we have generated a response vector multiplying with x beta, where beta is 5 and 10. We have fixed that beta value. Now, try to estimate the beta using linear model with two different decomposition methods. Let's try with pure decomposition method. Then we'll try with Cholesky decomposition. Okay, we can see that pure decomposition method that estimates of beta using pure decomposition method, it gives perfect estimates 5 and 10, and estimates of beta using Cholesky decomposition method, it is also given the perfect estimates of the beta 5 and 10. Since the condition number of the design matrix is only 3.13, well condition, so there is no difference in accuracy using pure decomposition as well as Cholesky decomposition. I'll create a design matrix intentionally with the higher condition number. Okay, I have created one design matrix X. Now let's check that condition number of the matrix. It is 3520.4. It is in the scale of 10 to the power 4. It is less than 10 to the power 5. Now regenerate response vector and try linear model pure decomposition method. Okay. We can see that estimates of beta is 5 and 10, which is a perfect fit. Now let's try with Cholesky. So here beta estimates of beta is 5 and 10. Perfect. Now let's increase the try to increase that condition number of a matrix. So let me take 4. 10 to the minus 4. We are generating a new design matrix. Condition of the design matrix is 35204 point something. It is in the scale of 10 to the power 5, but it is less than 10 to the power 6. Now regenerate response vector. We can see that estimates of beta using pure decomposition is the perfect estimates. Now for Cholesky also it is a perfect estimate. Okay. So what we have observed, 10 to the power, if the condition number is 10 to the power 6, in this empirical example, if the condition number is less than 10 to the power 6, the pure decomposition and the Cholesky decomposition in the linear model giving the same accuracy. Now try to increase a bit. Now condition number is in the scale of 10 to the power 6 and less than 10 to the power 7. We are getting perfect estimates using pure decomposition. Now we can see that estimates using Cholesky decomposition is little different from that other. Okay, so now increase the condition number a bit. Let's manipulate X in such a way that condition number is in the scale of 10 to the power 6, and it is less than 10 to the power 7. Okay, still I'm getting perfect estimates using QR decomposition, but you can see that accuracy is decreasing as the condition number increases. The very high condition number, the matrix is, we can say, ill conditioned, but we can see that QR decomposition method, the estimates using QR decomposition method, still it is giving the perfect estimates. Oh, now the Cholesky decomposition method, it is giving that positive exception, that is not, matrix is not positive definite. So X prime X matrix is not positive definite. So according to Cholesky decomposition method, it is a singular matrix. Okay, so when that condition number is greater than 10 to the power 8, we can observe that Cholesky decomposition detect singularity in that X prime X matrix. Okay, but you can see that QR decomposition still giving that perfect results. Now let's try to increase the condition number a bit. So now the condition number is 3.5 times 10 to the power 9. Let's regenerate the response vector using new design matrix. Okay, still I'm getting the perfect estimates using QR decomposition method. And we know that the Cholesky again show that positive definite error. Okay, now 10. So it is 3.5 times 10 to the power 10, the condition number. Still I'm getting perfect estimates using QR decomposition, right? So now we can understand why we usually say that QR decomposition is very stable method, numerically stable. Now 10 to the power 11, 22. Yeah. So the condition number is 3.5 times 10 to the power 11. Now let's regenerate the response vector with new design matrix. Okay. Now we can see that it is not a perfect estimate. It is perfect up to 3 decimal place. So now the condition number is 3.5 times 10 to the power 11. So it is less than 10 to the power 12. So in this case, the QR decomposition method it is not giving the perfect match, but it is giving up to the estimates of beta is correct up to 3 decimal places. Now let's increase the condition number by the scale of 10 to the power 14. So it is greater than 10 to the power 14 and less than 10 to the power 15, the condition number. Now let's see what happens. Okay, we can see that the accuracy decreased So instead of 5, that beta 1 is 4.88092, and instead of 10, it is 9.2499. So it is correct up to 0 decimals. And now try to increase the condition number. Oh, now the condition number is greater than 10 to the power 15. And your decomposition method also detect multicularity in that singular matrix. Since we have dropped cularity equals to true, so that is why instead of throwing that error, it is estimating beta, but it is that using the QR decomposition method, we are able to estimate only one parameter. So let's try that with Cholesky decomposition method. Again, it is throwing that error. Now let's drop coordinate equals to 2. So it is. Okay. Now you can see that the QR decomposition and Cholesky decomposition both detects multicularity in the design matrix. Okay. So what we have observed in this empirical examples, when the condition number is say 10 to, in the less than or equals 10 to the power 5, then your decomposition and the Cholesky decompositions both giving almost perfect results. But after that, the accuracy of the Cholesky decompositions decrease as the condition number of the design matrix increase till 10 to the power in the when the condition number is less than 10 to the power 12, the QR decomposition provides that exact estimates. But after that, as condition number increase, that accuracy using QR decomposition also decrease. And when we see that the condition number is greater than 10 to the power 15, then Cholesky decomposition as well as QR decomposition both detect multicularity in that design matrix. And previously we have seen that when the condition number is greater than 10 to the power 8, the Cholesky decomposition detects multicularity in the design matrix, that X prime X matrix. Okay. Now let's try a logistic regression with 5 millions of rows and 25 covariates. Let's randomly generate the design matrix and the response vector. And using benchmark tools, let's see what is that memory used by the QR decomposition and the Cholesky decomposition, and what is that running time of GLM with QR decomposition and the Cholesky decomposition. Definitely we'll see that Cholesky decomposition will require less amount of memory, since the X prime X matrix, the order of X prime X matrix is only 25 plus 25. It is a small matrix compared to that X matrix, which is 5 million cross 25. So Cholesky decomposition will definitely require less memory, and your decomposition will require more memory. So we can see that your decomposition estimated memory size is 6.85 GB in this case. And it took 21 seconds to evaluate the logistic regression, or 21 seconds to perform the logistic regression using keyword decomposition. Now let's wait for Cholesky decomposition. Yes, it is finished. You can see that only 2.12 GB RAM is required. And the time, you can see that it is taking 7.467, so almost 1/3 of your data. So what we can conclude from this exercise? So when we have very stable design matrix, the condition number of design matrix is say less than 10 to the power 5, then we can use Cholesky decomposition because it will give the same estimates but with less time and it will consume less memory. That's all. Thank you.
I think for questions, it's better if I just connect you directly with Mosam. So if you contact me outside, then I can connect you with Mosam if there are any questions on this. There's one last talk on another package that we're building. It's called crraw.jl, and it's for regressions. It's similar to the Zelig package in R.
Hi guys, thank you for giving me the opportunity to present this work in JuliaCon 2023. So in this talk, I'm going to talk about Bayesian analysis with horseshoe prior using crraw. So here is the outline of my talk. So first I will talk about some Bayesian Poisson regression. Then I'll talk about Bayesian logistic regression. I will briefly talk about Gaussian process models, and I'll touch upon the future work that we are doing in the crraw package. So in the Bayesian Poisson regression with crraw, first I'll talk about the maximum likelihood methods, then different Bayesian priors like Rich prior, Laplace prior, Cauchy prior, T-distributed prior, and horseshoe prior. All these methods and priors are also available for logistic regression and simple regressions and negative binomial regression as well. However, today I will just give you the demonstration with mostly Poisson regression. Same way you can do it using for the other regressions as well. So the first we have to call CSV data frames and crraw and statistics package. So first what I will do, I'll call the data set from this website called footballdata.co.uk. So from this website I downloaded 2 years of English Premier League data, 2020-21 season and 21-22 season, and we will use 2020-21 seasons data to train the model and then 21-22 data for testing. In the data set you have several variables. FTHG stands for full-time goals by the home team, and this will be our target variable. So since this is the number of goals scored by the home team during a match, so it is a count data. So Poisson regression is absolutely correct kind of a model of possible. Poisson regression is a good choice to model this kind of variable. Other than that, you have different type of other variables like number of shots on the target, number of shots in the number of corners by home team, and all these things are available. So here we have little bit space constraint, but all these variables definitions are available in the website. So the first thing is read the data as a train and test. So 2021.csv is the train. We are going to read it as a train, and 2122 as the test. Then we will consider the model. So FTHG is the number of goals scored by the home team in full time. We assume that it follows Poisson distribution. I stands for the match, ith match. In the ith match, how many goals scored by the home team? That will follow Poisson distribution with the sum rate parameter mu I, and log mu I is equal to xi transpose beta, and I runs from 1 to n. N is 380. In a season, there will be 380 matches that will be played. So first, we will do a maximum likelihood estimates. So using CR-Rao and stats model, you can define your model. Just call the fit and @ formula FTHG tilde sign. HS is the number of shots taken by the home team. AA stands for number of shots taken by the away team. HST stands for the number of shots on target by home team. AST is the number of shots by away team on target. AC is the number of corner by the home team. AC is the number of corner by away team. And then I have taken a two variable, which is a bit of an odd variable, but interesting in a sense. B365H is the Bet365 is a company, betting company, which gives odds of winning of the home team, and B365A is the odds for winning for the away team. So these odds are also available before the match. So I use those odds also for as a predictor. Then comma, you just give the data set name df train, and you have to mention the class of the model, which model class you want to fit, Poisson regression we want to fit. So if you just choose that and run it, now you can see that the p-value for HS and AS is a bit small. AS is not that small, but barely 1 at 10% level of significance, but HST is definitely very small. Z value is 10, then HC is small, also B365A is also small. So these predictors do have some effect, particularly number of shots on target by the home team will have a very strong positive correlation, has a very strong positive, because coefficient is also very large, 0.23, where other coefficient are very 0.0, say after first decimal, but HST is very strongly correlated with the number of goals. Now, what are the inference we found? So the following variables will have the effect on the number of goals scored by the home team. So number of shots taken by the home team, we see a positive association. HST, number of shots taken by the home team, has again positive. Number of corners by the home team, we found a negative, which is a bit of a odd, and odds of Bet365 away team, which is positive. So these third and fourth observation is a bit of a questionable, what we would say, from the likelihood analysis. So the first thing we are trying is a Bayesian analysis with a reach prior. So the likelihood part is same. Now we are inducing a prior distribution on the coefficient beta. We are saying p-variate normal 0 lambda I, and on lambda we put a inverse gamma with h and h. So by default h take 0.01, 0.01, but you can, if you wish, you can choose the h as well. So now you see that rest of the in CRRAW, everything else is same. So defining the model, DF train, Poisson regression, same. You just need to mention prior is reach, prior underscore reach, and that's it. You just run it. The CRO will automatically understand that, okay, you are calling for reach prior with Poisson regression. It will call Turing and it will run the Hamiltonian Monte Carlo on this model and it will give you the results. So it was pretty fast. Similarly, we can, if you want to try Laplace prior, Bayesian regression with Laplace prior, on beta j you put a Laplace 0 lambda and lambda follow inverse gamma. Now everything else is same, only in the prior, instead of prior underscore reach, you just say prior Laplace. So now what I will do, I will just run this piece of code and it's decently fast. Similarly, you can run Cauchy prior. The Cauchy prior, the way we have modeled it here is we just on beta j we induce t distribution with 1 degrees of freedom with scale parameter lambda, and on lambda is inverse gamma. So t distribution with 1 degrees of freedom follows Cauchy prior. So this is a prior. This is an interesting prior in a sense that it does not have any mean, variance, no moments exist. So it's a proper probability distribution, but it does not have any proper moments. So essentially, you cannot make any guess about the mean or variance about the prior. So in a sense, it's a very flat. Its tails are much flatter. So all you have to do again in the CRRAW, everything else is well defined. Like, you just same model, same data set, same model class, just say prior underscore Cauchy, and that's it. You just run it. The Poisson regression with Cauchy prior will run, and it will give you the fitted model. Similarly, you can do it for t distributed prior. So t distributed with new degrees of freedom, and new follow inverse gamma and lambda follow inverse gamma. And again, if you want in t distribution, you have to default it. All the model runs for 1000 simulations, but what my experience is, t distribution you need to run a little bit longer in order to achieve a convergence. So I'll come to the convergence issue very soon. There are what my experience is, reach, Laplace, even Cauchy will give you a nice convergence even with 1000 simulation, because these uses a Hamiltonian Monte Carlo which works much better than simple Markov chain Monte Carlo. On the contrary, t distribution and horseshoe prior is bit, you need to run a little bit more. So here what we are doing, we are saying that, okay, Poisson, it's my target value variable follow Poisson and this likelihood, and then each beta j follow normal 0 lambda j tau, lambda j follow half Cauchy with 0 1, and tau follow half Cauchy with 0 1. So lambda j behaves like a local shrinkage for that particular, for coefficient specific shrinkage, whereas tau follow a global shrinkage, it's control the global shrinkage of the entire model. So this is a very interesting prior. So again, all you have to do, the same model, same just training up to this, you are exactly same, and then here you just mention prior underscore horseshoe, and then 1000, you just 10,000. I have default is 1000, but I made it 10,000 so that it runs quickly, and it runs a slightly longer chain and gives, hopefully we will have a convergence. If we don't face a convergence, then what will happen is we have to run it again. So this is a bit of a painful process. You may have to run to like maybe 20,000, 30,000 simulations, which doesn't take much time. For a moderate size data, it might take 5 to 10 minutes, but it does decent job compared to if you run it in say R or Python. So okay, it's done. Now I'm saying that okay, show me the model performance. Okay. Okay. So what we are seeing, you can see most of these R hats are very, very close to 1. Since most of these R hats are very, very close to 1, so we can we can say that yes, looks like these this horseshoe prior with 10,000 simulation, Monte Carlo simulation from Hamiltonian Monte Carlo chain has worked reasonably well. And when I did the analysis, and then what we found with the Bayesian Poisson regression with the horseshoe prior is the number of shots taken by the home team was positive. It was same as likelihood analysis. Number of shots on target by home team was also positive, and it was same as likelihood analysis. Number of corners by home team was negative, same as likelihood analysis. What we found that odds of bet 364 for away team does not have any effect. In likelihood analysis, we found that bet 364 does have a positive effect. So this is a interesting way. It's typically what happens with the horseshoe prior. If a particular coefficient does not have an effect, in likelihood analysis might show some weak effect, but with the horseshoe prior you will find that it will get rejected, and in fact it will be like you will not find any effect for those kind of weak effects. So if you do the plots of the chain, okay, so what we are seeing here that, so remember that the chain has converged for the lambda. This is the tau nicely sort of a chi-square type behavior. These are the lambda values, and they have a very kind of thing. Now here is the beta 1, the intercept is like, and this is, you will always find like something is not does not have an effect, will have a very sharp sharp mode at 0. So, and that beta 2, which is probably home team shots, is has an effect, so it is completely on the negative side. Okay, then beta 3 also sort of almost like negative side. Beta 4 is completely positive. Okay, now beta 5, you can see a very sharp positive mode at 0. So that means beta 5 does not have an effect. Similarly, beta 6 is almost mostly in the negative region. Beta 7 also very sharp mode at 7. Anybody which has a sharp mode at 0, we can just drop them from the model. So this is typically, so here beta 9 looks like it is inside the 95% confidence interval. So this is how, so that means that this was the beta 365. So we can say that yeah, it looks like does not have any effect, so we can drop them. So here I have done a small model for Poisson regression with the horseshoe prior. and if you just plot them, so here is the full model. So you can say this is the intercept, which is a negative sort of behavior. This is the negative, this is positive, and this is negative. So what we are seeing that it has some, when we are considering a short model, its direction is getting changed. So this is always often happens that the direction gets changed, that means the interpretation gets changed, and this is always a problem with in typical statistical analysis. So this is, here is the statistics plot, all the statistics plot you can see. Now based on this model, I did a prediction on the test data set. Okay, now I did a predict. All you have to do, just call the model, whatever model you want to work on, call the model and provide the test data set, it will do the prediction. And then if you run this, so here is the prediction for 380 matches, test matches of the 21-22 season. All the seasons matches are here. So there is the approximated R squared that we have calculated here, 31.7 or 32% R square, and then we also calculated RMSE, so 1.14, and then we did a plot. So if you see the plot on the x-axis, we plot the predicted goal by the home team. On the y-axis, we plot the actual goal by the home team. So what we are seeing, this particular model is doing a bit of a overestimation. So because there are these goals, if you see these goals are in the range of 4 to 7, whereas the model is predicting 5 to 10 or 11. So similarly, these goals, these cases, these matches, the number of goal is somewhere in the range of 2.5 to 5, and whereas they are mostly in the range of 2.5 to 5. But at the same time, here these cases, you can see the prediction was somewhere in the between 0 and 2.5, whereas home team did score a bit of a underestimation has happened. So some cases it was underestimated, some cases it was overestimated, but looks like there's a slight behavior of overestimation is happening. So now we will move to the logistic regression analysis with Friedrich-Atschia data. So it is a bit of old data, but it's very popular, available in the R dataset package also. So from the R dataset, we will call this data. So from R dataset, you call the GPA package, from the GAP package, GAP package, the AFA dataset. And if you just run this, so this is the dataset. So this is the Y value. These are all coded as 0 or 1. And there are 12 loci from 1 to 12, they are codified, they are all typically integer. So here I have written a small function to split the dataset into train and test. So run this and then split the dataset with 70% for the train and 30% for the test. So here is the train dataset and here is the test dataset. Okay, you got a test dataset. So now if we want to run the maximum likelihood estimates, all you have to do formula y and give all the y tilde and then give the all predictor variable, then give the training dataset name, say name the logistic regression and say logit. So if you want probit, then it can call it probit. If you want a Cauchy link, you will give a Cauchy link. So there is a bunch of links are available. link functions, so you can we just use the logit link here. So you can see here the loci 3 may have some effect, okay, loci 3 may have some effect, and rest of the loci does not have any effect. Loci 11 may have a effect, some kind of weak effect at 10% level. Loci 12 definitely have some kind of effect, okay. So loci 3, loci 11 and loci 12 looks like have some effect based on simple likelihood analysis. Now, so that is what I have written. Loci 3 and 12 statistically significant even at 5% level, maybe at for 1 even, yeah. And loci 11 significant, maybe at 10% level, we are not so sure. So if I do a prediction based on this, and if I run this, this will give me the confusion matrix. So first 2 is 0 and 39 gives me all. So my test data is such that it gives all 39 negative values, and then 21 and 18. So 21 true negative and 18. So everything false positive were given. So if you change it to 0.5 to 0.7, then you can see that it has 21 to 29. True negative has gone up from 21 to 29, and false positive has come down. So this is now similarly for this model we can apply Bayesian logistic regression with horseshoe prior. Yi follow Bernoulli Pi, and Pi we have taken logit mu I. Mu I is xi transpose beta, then beta j follow normal 0 lambda j tau, where lambda j is the local shrinkage and tau is the global shrinkage. Now lambda j follow Hopf-Cauchy distribution and tau follow Hopf-Cauchy distribution. For each coefficient we have a lambda j, and it plays a role of local shrinkage. Same model, almost no problem. All you have to do is just call the fit formula, provide the formula, train logistic regression logit, and then just mention prior horseshoe, and then you are done. So and then if we just show, so what we are seeing that we are not facing much of a problem. Most of the R hats are close to 1, so I'm sorry, I think the font is bit of a small problem, but most of the ones, there is 1.3 is there. So if you want to make sure that it is run, it is absolutely converged, then you may have to run once more. So let me just do a plot. So you see tau and all these things may have, looks like it may have some convergence issue. So lambda 1, 11, looks like it has. Beta 0 is absolutely very sharp, beta 3 is here, beta 3 is bimodal, has become bimodal. So maybe we think of running it once more. Let's go back and run it once more. Let's run it once more and see what happens. So if it runs once more, it doesn't start from the scratch. It actually keeps the history and it uses it. So essentially you are starting from 11,000. Okay. So now if you run it, okay, and maybe, So okay, now it is bit of a, so as I said that convergence is always a bit of a issue, so you may have to run it for a while. Yeah, now looks like it has converged. Yes, looks like it has converged. So this is beta 1. You can see beta 1 is all 0, and then beta 2 is also very sharp mode at 0. Beta 3 also made it 0. Beta 4 is not 0, looks like entirely positive. 5 is have a very sharp mode at 0. Beta 6 also have a sharp mode at 0. Beta 7 has a sharp mode at 0. Beta 8, beta 9, 10, everything has a very sharp mode at 0. 11, 12, see 13 does not have any sharp mode at 0, it is completely negative. So as we discussed that so 3, 4 except 13, it turns out everything else has a very sharp mode at 0. So now finally I would like to discuss a little bit about Gaussian process regression. We are implementing Gaussian process regression and we are just now doing some tests. The development is completely completed. So we are using Gaussian process package in Julia, Gaussian processes.jl. And what our plan is basically by end of this month, I hope it will be integrated and it will be released. So now from our data set, we are calling the empty cars data set. Okay, and all you do, just provide the formula, provide the data set, and then call the Gaussian process regression. That's it. If you run this, then it will do the analysis for you. So target variable is miles per gallon and weight is the index variable. We will be consider weight as index variable. And if you draw this model, if you ask the plot, so you can see the plot weight is x-axis and on the y-axis we plotted the MPG, and it fitted a nicely nonlinear regression with a 95% confidence interval for the curve. So it is very nicely done. So this will become very useful for a daily analysis, somebody who wants to do a simple nonlinear regression. So currently we are planning to implement we are planning to integrate ARIMA from statespace.jl, k-means clustering, mixed models.jl, stepwise. There are some students who are working on stepwise selections, variance inflation factors, and Bartley's rank test. So here is our GitHub page on CR Rao. Please do support us, star us. That will be a very helpful. And thank you very much.
Yeah, so for questions, you can connect with me or you can email him, message him on Slack. I think that would be the best. I may not be able to answer these questions. So that's all. This is the end of the symposium. Do not come back at 2 p.m. That's all. Thank you.
Yeah, I know.
Okay, you're speaking
All
of
my
JSON.
stats.
You're speaking of the JSN section.
Yeah.
Nice to meet you.
Yeah.
Yeah. So I'm Josh. Good to meet you.
Good. Yeah.
I've also seen online stats. Oh, cool. Good to meet you too. Yeah. Yeah. Excited for JSN, but
So actually, this conference gave me an idea to reshape a bit what I, but only slightly what I
you
will.
can change whatever you want.
I assume, yeah. But like I can tell you.
I've given completely different thoughts.
Yeah, but what I realized at this conference, because I wanted to talk about the spectrum of tabular data formats you can work with Julia. I will keep it, but actually the talk made me realize that what Julia provides that is pretty unique is that people have different expectations about software.
was 2 hours long, not 3. So it finished at 12:30. Yeah, so there were 3 sessions. So 10:30 to 11:30 and then 12:30. And then we will have more content for our
But yes, that piece will be open source. The basic idea is you store data, data changing. Suppose I have a gigabyte of data today. It could be that somebody will backfill some of those numbers, and we, for regulatory purposes, have to know exactly what the current that particular data. But if you're changing 1K data out of a group of data, you need one of those things like flips or exception. So it's,
I guess, have you ever looked into like brokered message queues?
no.
So like they're systems that are basically built on the idea of having it's basically it's essentially a database, like a distributed database. The whole point of the database is for people to be able to publish events into the database and then subscribe to them into the database. But the database itself keeps a robust kind of history of all the events that people subscribe to. Right. And so originally people started using these to be able to like forward messages between the services. But then after a while people were like, oh, actually if I want to make event for the database, I think this is one. And so people now have done things like you can use SQL to like query and store events.
That's interesting. Well, you see, we face a somewhat more difficult issue throughout our industry, which is what the vendors rewrite the simple databases and customers don't want any changes. So, it's gas. So we're to ancient ways of thinking about data. So what we would do is we would be querying those rewritten databases several times a day, and then reading them.
Right, because you have to like pull things, I guess, pull information on demand from vendors. You're basically aggregating all this so that they're like,
So, but fun issues.
you do I think it's a little bit different. You're talking about a problem when you have a live data
40 years ago, it was called Andros. Well, close. I mean, not but I lived by Webster Avenue, you know where that is? I used to live, I lived on Webster Avenue. Oh, you came close, you guys. Okay, I lived in the same block. I lived in 64 Webster Avenue. That's so funny. And it was, I grew up in rural Iowa. Put my bike together my second grade. Didn't know where I was driving. I had a lot of, I rode by one of the housing contracts and so was shy.
There was a, I think that area just Cambridge was pretty sketchy.
Oh, it was sketchy. The second day we were there was this, no way to describe it except teenage hoodie on the street who knocked on our door. He essentially wanted to come inside to see if we had anything worth stealing.
At least he knows.
And then we don't have books now. He's not particularly. And then 2 weeks later, he came by carrying a colored television and wanted to sell it to us. So it was interesting. I just looked on Zillow and that building is now worth $1.2 million. It's just wow. That's money. So there's a there's still a little grocery store there on that.
There's on that block. Like a tiny corner shop.
Yeah, exactly.
Yeah, that was that. That existed back there?
Oh yeah.
Oh wow.
That's very funny.
There's still, I remember when we lived there, there was a lot of package back there. That's everywhere.
Yeah.
And there's certain parts around but yeah, the housing situation is crazy. Well, you talk about development around Google Square.
Yeah.
Big, super fancy apartment buildings and great streets and Google Square. It's like every pricing of everything.
Well, but and the interesting part about it is that employment and prices and everything are not crashing here the way they are in San Francisco. My younger daughter lives in myself and just from out visiting here which is it was worse than Harvard Square. Well, she they're just moving right to right next to Britain Park, which is that's jump through the train. But no, this is really well proposed.
It's there's like a certain vibe, I guess, of the community here.
Yeah, no, I really feel it. You can just feel it. People ask lots of good questions. You can just, and there certainly is a lot of energy. Now, have either of you guys tried 110 yet? I just came here late because I spent the last hour downloading 110 and all the packages. Well, it's the next version of 1.0.
Oh, of course. Yeah.
1.10.
Yeah, that's right.
Sorry.
Yeah, no, that makes sense.
No.
I haven't tried it yet. We also, so how
Like I'm used to just task switching often.
No, I think at some point, like, we've been incubating this. I know it's like open source, but it's not really. We haven't like advertised for it. We've been incubating this package called Legos.
Yeah, so that's why I added this support for abstract row to data frame.
Really, because of that?
Yes.
But I think like, yeah, I want to get it. There's like a couple of things that need to happen.
Because you have custom abstract row in the code, right?
I want to say.
Yeah, so that's why just so that it interoperates easily with data frames.
Yeah, no, that makes it super easy for us. Because yeah, we basically have this way of like, it's almost like an interface definition framework, but for like record types. So rows.
Yeah.
But yeah, I want to get it like eventually. If I have time to actually code these days, I could do this. But sometime I want to get it to the point where I can take it out of Beacon and maybe put it into the data and then have it be a less weird name and have it be like a general framework for defining record types. Because I think at Beacon at this point, it's pretty. I think we battled that quite heavily. Maybe too heavily.
The question is, because I have not used this much, is it for end users or rather for package developers?
I think it's for end users if they are operating in an environment where they're like having to build their own internal like data ecosystem. So like we have a lot of data scientists that we can dealing with all sorts of data all the time. And what people really like to be able to do is like they want to be able to both reuse other people's schemas for data that has like common aspects.
So it's like kind of ORM?
No, because it doesn't. No, because it's not necessarily tied to the data.
Yeah, I know that's not specific, but in general, like a specification of the layout, but probably not physical but logical, right?
That's right. Yeah, it's basically that. But the cool thing about it, I think, is that it's the extensibility and composability statistics of it, and then the fact that it incorporates like a versioning scheme for every single different thing. And you can load different, like it actually comes up a lot with us, like being able to load multiple historical launchable versions of the same schema is really useful. And you can do things like introduce schema changes without the need for it to change the package.
Yeah, so in general, I think this is like missing piece in version history management.
Yeah.
Like what we discussed a few minutes ago, where most people assume that schema is fixed, but just data can change. For example, that you have reference data that changes, but in general schema is fixed, but in reality schema changes all the time.
And it's like, how do you deal with the fact, like, when you have, I think it's also if you're like one person, or if you're like a couple of different data sources, but if you're like an organization of people, and everybody's working on different data sources, but like, it's kind of a many-to-many mapping between like groups and data, and like, what they're trying to do with the data, then you get into these situations where like, how do you get people to like reuse concepts between each other? How do you incentivize doing that? Because people don't necessarily, they want to do that, but then they won't do it if there's any overhead, or if it like locks them into something that's bad.
Well, you know, corporations, like I'm sure you probably know that, will try to solve this using this feature store concept. But
yeah. Well, in feature stores, it makes sense when you're doing actual features, but even for like very traditional.
yeah, but I think feature store is kind of limited because I don't know how Legos works internally, but I assume that you can keep that this is a record and some relation between objects within this record. It's not just a single field, right?
Yeah. It operates as at a whole record, but it's just a logical specification. Like if you wanted to, like for example, our platform uses the semantics of that logical thing to
what like would be the thing that we could like discuss to, because I understand that your idea would be to like promote it more.
What I want to do, I just want to get it to the point where there's a certain place where I want to get it. There's like a couple of different like, features that I want to implement on it. One is having like a system for more interesting like constraints, like specifying constraints as part of your schema. And then
with the validators or
the validation story is already. I mean, the constraints would be another way of specifying things that also tie into validation, but I think the story of validation is already basically there.
So what would be the difference between validation and constraint?
Constraints would be a nicer way of expressing things that you would like to validate. So right now, like you can do whatever validation you want, but
okay, so it's like UDF, right? Like you can write a function that it validates, but I understand that constraints like.
So that's what it already supports. It's like you just use arbitrary Julia code to validate whatever you want. But sometimes it's actually useful if there's a more constrained expression to like say what you're trying to validate. You know,
integer range or something. For the
So and then we can do things like tie it to nice error messages and stuff.
And people actually ask about it. So what then could be done, like just verifying to you if this is something that you think makes sense, that you could attach this specification to a data frame and a metadata, and then ensure automatic validation whether your data meets this metadata constraint.
That's right. That's right.
Since data frame like propagates metadata, it's never lost.
Yep. And so that's actually one of the reasons why we were interested in the like the table level metadata or data frames a long time ago, is because we do proper.
And you do. You do this? Okay.
But yeah. So but the two things there I think I would want to work on more is some like adding more features based on like constraint stuff, and then another thing is multiple inheritance. So there's a notion of like extending schemas from other schemas in this thing, and it can support like multiple inheritance essentially, which would make things very convenient. So I want to make sure it supports that. And then documentation. But if I can do those three things, then we can make it out of incubation.
Yeah, and then if it's there, I would, at least for this area of this constraints slash validation, add it. I will need to look how to do it, but add it to this table metadata tool so that really people like start using it and discovering it in a more natural way, because I don't know, I like Legolas name, but probably it's not super discoverable what it does.
I name it that way explicitly because I want it to stay in this mode of not being too overly used by the people yet. But I think
he was afraid that it would get such so he chose a name so that no one knows what it does.
yeah,
You could just have random characters.
That's right.
Changing the version.
I understand he did, and it ended up being Legolas.
But I'd probably name it like records.jl or something really simple. I also wanted to name it like optical records but that's too fancy. Because it uses like the concept of how it works, the composability and extensibility it comes from like optics basically.
But optics or like you mean the lens from the
because it takes the view of like this is like very conceptual, but like part of the way you derive the semantics of it is like imagine that all data is stored in just one big table, and then every record, every schema for a record you could ever talk about really is like a lens on that table.
Yeah.
And then you start saying like, okay, well, what can you do when the lenses overlap, and when you take one lens and expand it to mean another lens.
Yeah. So I think that the best.
So few people probably know that semantics that I don't even really talk about it, but that's how.
Yeah. But the best thing about what you say is that you actually tested the design.
Oh yeah.
I think that it's really, so I think that this thing to get it right is really hard. So really, if you say that you've used it already for some time, it's really, reassuring that it's stable.
Yeah. Well, it will be stable once I do these things. That will probably make everybody a beacon that because we'll probably break things. But no, like I don't think we can do it. I agree with all of the stuff. But yeah. No, I mean Beacon at least is 60 or 70 people, and not all of them, I guess, are programming, but a lot of them are. And then if they're interacting with their data at all, which is most people who are programming, then they're using the system. I do think what's interesting though is that like I'm curious what other people of the Julia data users of the Julia data ecosystem have. Like this is solving the kind of problem that only appears once you like are working with data between multiple groups of people in an organization. And so the question is, a lot of Julia data users are probably academic users, so it's not kind of the same.
I don't agree because I think that for me, of course, your use case that like multiple teams, for sure, but the major thing is that even if you have a small team, but that needs to maintain something over like 10 years.
Yes, absolutely.
Yeah.
Yes.
Yeah, because this is, and this, you are better to say this than me.
Because, there's the time series and then there's the cross-sectional issue. You're thinking about that data is shared cross-sectionally. You're thinking about that data is shared over time.
Yeah, and it's even for a small team, it's always like this.
Always.
It's like so, at least for me, so obvious that it even doesn't need explaining. It's like you have it all the time. For example, I support Polish Ministry of Health, where we are tracking every patient, like every year and so on. What was done? Schema changes every 3 months, and you have 10 years of data, and then you ask, okay, let's ask, how many times this patient had some kind of, treatment. Impossible, because 5 years ago it was a different table, different name, different everything. It meant the same, but
think about it as the methods for automatic data collection increase. Automatically, we have much larger schemas than we had before, and that trying to map things on a longitudinal basis gets to be almost impossible.
yeah, especially got much worse kind of when this concept of data lake got introduced, because before, in enterprise level, they tried to keep enterprise data warehouse where there were some team of people trying, keeping the history but trying to retain the single schema. But with data lake they say, store it later, you will do something with it.
Schema on read.
Yeah, but when this later comes, actually it's a huge project to read.
Because nobody knows what was really collected.
Yeah.
We don't have the experts in the original data.
I do think that there are interesting queries, schema on read queries that do that well, as long as
No, but you need this Legolas part to do mapping.
I think the Legos thing only really is a value add if you're trying to maintain a good schema on write system. It probably doesn't matter as much if you only care about schema on write. Like if you say, I don't know what the schema is of So I didn't go this morning. I gotta watch them.
Yeah, sure. But we might, if you have time, but no rush, of course, we can do it later. We could spend 5 minutes before 3 because the 3 is there's a better time. I can show you what I think is missing and we could discuss like whether you think it's worth adding to the other or not.
Do you want to show me right now?
Yeah, if you have time.
Yeah.
Because it's not long and everything is on GitHub and I gave the links, etc. But just probably, you know, just chat for a second. No, not all, because part 1, because part 2 is time series, which clearly JL does not cover, and then there is panel data, which again, not real MJL, more likely mixed models, and you know, instrumental variables and such things. So what is in general missing? So I'm using the R notation, so HDCO, so you know, robust robust estimators. I don't know if you know the shortcut, but S means like standard, and there is robust of like 1, 0, 1, 2, 3. And I implemented all of them. In general, this is heteroscedasticity robust. And this is something that is missing, and I think we should add it. This is implemented right now also that it should properly take into account weights. But
yes, the weight stuff is important, and if you're doing heteroscedasticity stuff, you should do Newey West corrections for serial correlation as well as the adverse
This is one thing that is missing. Then the other relatively simple, and I didn't try to, you know, write it neither efficiently nor super nicely, but like LM test, just Lagrange multiplier test, which was missing, I think. At least I couldn't find it, and for sure, word test, I don't think, and it is actually, I think this is an important thing that is missing. I didn't again try to write a super nice interface. I assume you just specify it using matrix, but like if you want to put constraints like first coefficient plus second plus third equals 0, we don't have a test for this, and I think this is needed. So this is, so the only thing we have now is like if you have a model and a constraint model, you can test this.
Yes, yes.
But in this area, I didn't include it here because it's easy to be done, but what we are missing, and for example, Stata does, is the following, that you have a larger model, and then you have a constraint model. If in the columns that you removed were missing values, you actually will have more rows in constraint models, and you cannot you cannot fit it like this. And so again, it would be good to have a nicer interface that would actually make sure that if you have a full model and constraint models, that you ensure that they have matching data on which they are trained. Because this is now has to be done manually, and like
so something like drop.
Yeah.
So likely they are projected as anything drop.
Yes. So what we have now, if you do this F test, you have to create both models earlier, and if data has missing values, you will have just not matching models, and just very error prone. It would be better to have F test, but actually where you only specify formulas and data, and it would actually make sure that everything matches.
We have internal code because this works.
Oh, so
yeah.
Because otherwise it's super error prone. So this is the next thing. then something I think doesn't need to be included, so least absolute deviations estimation, so the different penalty, but I think it's not super important. Analytic weights, I added them tentatively, but I, soon had them. And then the last thing that was missing from like basic calculations was studentized residual. Because for them you need to. So I actually have that. Oh, very good. Because again, I just again, I didn't try to be super efficient, so like I just manual invest and so on. I just quick and dirty, but again, this is something to be added. So out of this list, I think the most important thing are work test, I would say. Maybe this F test to make sure that models match, and this heteroscedastic consistent error, because this is something, and I guess you will agree that this is often needed, and people ask if you have heteroscedasticity and if your errors are heteroscedastic zero.
Well, and particularly, also in longitudinal data, having the series correlation.
So this is for the mixed models probability request. I'm a mixed models. So GLM is for cross-sectional. So then mostly you care about heteroscedasticity, but of course if you go into time series dimension, You don't need more homework. So everything is there, except apart this comment about F-test, because I implemented it like I used F-test. I just made sure that I have a proper data frame for estimating those models, but maybe we can make it.
Yeah, but it's really easy to have F-test methods bar art formula. Dave, we're going to be talking again soon.
And I just say, as a native English speaker, I'm very jealous of your ability to say the hetero word that I can never say. It's heteroscedasticity.
Yeah.
Consistent every time, and I'm very jealous of that.
Well, that's why you have to be heteroscedastic consistent.
I want to introduce myself after your talk. Kevin, we've interacted a ton.
Oh, yeah, absolutely. There you are. Yeah, actually,
Like that, something like your.
that was the whole idea.
I was very shocked at that. I thought
That
it
was the whole concept. Yeah, that's why I've had that stupid E1 avatar for like years and years.
But yeah, I just wanted to say hello.
Yeah, we interacted a lot. I think, I'm pretty sure you were the person who got me using Pivot. Which greatly improved my life. I was very worried at first at the lack of and I mean, basically, my conclusion was I used the shell itself for scripting and stuff little enough anyway that I just don't give a shit. I'd rather have a better shell.
When you need to go to a public server that has an install fish, as I occasionally do.
Yeah.
Okay, I'm just going to limit my exposure to that as much as I can. And like,
That was another thing that made me that was another thing that made me hesitate to use this because that does happen to me occasionally. But yeah, Bash is terrible. CSH is
Okay, so let's see if I can get it working. Yeah. So welcome everyone to the last session of the Julia data stream of different sessions. And I would like first to thank organizers for allowing this. Jacob wanted to be here, but for personal reasons he had to leave the conference in the midday today. So what is this last session? So we have birds of feather. future of Julia ecosystem. So what general objectives we have set for us? So there are three things. First, to discuss what things we should work on in Julia data. If we have this, to identify priorities for the development of packages, and in general, what is missing or what should be added, so on different levels. So how I propose we organize ourselves is that in order to make sure that we can achieve those objectives, someone has to take notes so that later we can transfer it into issues, PRs, or whatever. So I will do this. And later, like, have a summaries of this. And everyone else, of course, I will also try to chime in when I would have something to say. Is invited to share ideas, comments, proposals, etc. Christian, if I could ask you, because just to make sure that everyone hears each other, that like if someone wants to say something, could you pass around the mic so that when I'm taking notes, everything runs smoothly. So this is how I would propose what we organize. And the second thing is just to kick off the discussion, and I will keep it like visible for a second. This is not something that we are tied to discussing, but those were the ideas that before the workshop people said that this is something they would think is relevant and important for further developing the ecosystem. So first is, in general, integration with databases, both SQL and NoSQL. And under this, in particular, is something that I had already several talks during the conference. For example, how do we make sure that we have a smooth integration with data stored in S3 and that we can really easily get them, process them, and save back. Second is data processing pipelines, in short. So we have tools that do particular steps in some processing pipelines, but the question is, do we need to develop packages or functionalities that actually would support in a more advanced way that change.jl, writing monitoring pipelines? Probably here are folks from industry that are facing this challenge and could comment what they think is needed. Third point, several people mentioned GPU acceleration in tabular data processing. Maybe it's needed, maybe it's not, but like there are for sure areas where it's needed, but then there is also a limitation that if you have super large data, GPU is probably anyway out of question because of memory limitations. Fourth point is out of core, and we had already a very nice talk about the tables, but this is like a starting point. And a lot of people ask for what's the future of out-of-core processing. So this is, I hope, something also we could discuss. And last but not least is how to make it easier for users to start using the ecosystem, in particular R and Python, because this is something that is currently probably the most common target user that knows already some of R and Python, and how to make it easier for them to start using our ecosystem, whether it should be tutorials or maybe some extra packages. Like, for example, we had this super nice talk about Tidier that really makes it much easier for people to transition from dplyr world to Julia. So those are like 5 points that were mentioned and we could discuss, but because it's birds of feathers, so I would like invite everyone to have an open discussion about anything we believe is important. And what I will do, as I have said, I will just take notes and make sure that share on Slack probably on data channel the summary of this, and then I will, where it would make sense or be possible, open issues in relevant repositories so that the ideas we have here are tracked. So again, Christian, if it's okay with you, just look who raises a hand, and I will grab there.
Sorry, I actually have to bug out a bit early, which is why I so eagerly jumped on the mic. So to me, the thing that really stands out in this list is Dagger and dtables and the distributed stuff. So in quote unquote big data world, a really big deal is Apache Spark. And so when I'm doing my work, I still know of basically no feasible alternative in a lot of use cases for doing what Spark is really specialized at, which is essentially really big distributed joins and group bys. And at a certain scale, there's just, no real alternative for doing that. And one thing that I see is also a lot of people using Spark to do all sorts of other things, or at least to call into other things like machine learning and stuff that they probably wouldn't otherwise use it to do if they didn't already need it to do these, essentially what it boils down to is massive joins and group bys. So, yeah, I mean, I guess the gist of what I'm saying is that I think there's both a challenge and an opportunity for the distributed stuff. I think that if it were possible to make a viable alternative to Spark out of stuff like Dagger and dtables, people might realize just how painful it actually is to use Spark in a lot of cases. But it's also a use case where at the moment you pretty much just can't use Julia or anything else for that matter, and it also creates barriers, like people are less likely to use it for something that would come further down the pipeline if they already need Spark to do that. So.
Before, I just got one notice because, so first of all, thank you that so many people came here, but I just got on Slack information that even people that are, not with us are watching what we are talking about. So just a quick request that, because, they can only see, the screen and don't know who's talking, just that everyone briefly introduces who is talking. I just got a request. So if for those of you for whom this is not a problem, just please comment. And now let's go back. So maybe even Christian is the one to answer your call.
Yes, so Christian Gulinski is speaking, the maintainer of dtables. It's a difficult question because, yeah, Spark is dominating and it's difficult to even plan to somehow replace it fully. I think we can definitely aim for the smaller use cases where people have some local data that's pretty big, and they want to process it out of core, but it will certainly be difficult to replace Spark fully where the data is, for example, stored in some cloud resources where the data is far. Because what you still need to do with Julia anyway, if we had dtables ready, is setting up your compute resources, which isn't trivial. So that's another entry barrier to this kind of technology. Because with Spark, you usually have a cluster available already. Setting up a Spark cluster is possible, of course, but that problem is usually solved for the common user. Yeah, if I were to say what the plan is, it's probably just for the common use cases where we have files stored locally or in some network attached storage, and we just want to process it out of core. replacing Spark fully is, I think it's too big of a challenge for this kind of project. We can probably just aim in that direction and cover some simple use cases of that, but I don't want to fight Spark. It's certainly a tool that has its advantages, and well, it does its job, right? And it's a big project, so we would kind of need the same caliber to even approach that.
Thanks for doing all the exercise, man. I appreciate it. Hi, my name is Cameron Pfeiffer. Is that a correct volume? Does that feel okay? All right, cool. So, one of the things about dtable that is like really nice is, so for some context, I'm an economist and I tend to work with like very large data sets. One time I had 5 or 6 terabytes that was stored in tab separated value. Okay, this is a dumpster fire of a project and I hated it. Many years ago, when Dagger was still in its infancies, I was like, come on, I need Dagger for this. I just want to do like some very simple group by reduce operations. And Dagger was just like having some trouble handling it. And I was like, okay, this is like not going to happen here. I think the only thing I need from dtables is just being like a nice way of constructing iterators for out of memory, out of core stuff. And I think that we don't have to like supplant Spark at all, because nobody who uses Spark actually wants to use it, I think, because it's really unpleasant. And I think just having this nice little thing that we can compose with everything else in the Julia ecosystem would just be lovely. I mean, it's a good tool already, and I don't think we have to try too hard to make it very pleasant.
Hands? Oh.
Yeah, I was going to ask if beyond just like doing the work of implementing distributed joins and that kind of thing, like beyond the algorithmic work, if there's any infrastructure we're missing, like ability to run in the needed environment or read the right kinds of file formats and like that kind of stuff.
Yeah, I mean, I would say as far as like, file formats and stuff, it's mostly there. Actually, some of that falls on me because Parquet is a really big deal in that world. I maintain probably what's currently the most popular Parquet package. But I mean, something I was thinking on those follow-up responses is, yeah, definitely I don't feel we need to do absolutely everything that Spark does. To what you're saying, Jeff, I think that if the ability to like create a useful cluster to run distributed stuff on like AWS, Azure, the other cloud providers with like basically one command would be a really big deal, because people have that with Spark right now and they're currently doing that. It's like, there's various different ways this is done, but a lot of people are just like, click this cluster is there. They're dropped into a notebook and it's like running on the cluster. Even a small piece of that, just like, one command so that the cluster is there, even if I didn't have like, notebooks and stuff, it would go a very long way to making up for that, I think.
So, Przemysław Szufel, I wanted to add to the discussion that I always thought that one of the advantages of Julia is that I do not need to use Spark. Is if you, for example, ever try to install yourself Spark on AWS, unless you use some inbuilt services that have a big price margin on top and are not so nice to use at all. And then if you need to install it yourself, it takes a lot of time and it's not comfortable after all. But regarding the file formats, I started to talk with Julian. I do not know if Julian is here. Oh, okay. So I've started talking also with him that maybe
maybe during tomorrow we'll have a look about the thing that you could have a file in S3 which provides a massively distributed access because you can open several hundreds or thousand connections to an S3 file as long as you saturate the entire network interface. And then have some distributed, on the other hand, have the file in Apache Arrow and have then a D table on the other end. And then you have something kind of like this, so you have distributing I/O, like nicely like HDFS you would have. And then you have distributed processing on the other side. So then suddenly, without Spark, you have as robust and as nice functionality, like, you know, storage is distributed and processing is distributed. So this is the proposal, or maybe somebody also wants to join us tomorrow.
Okay, so before we go to the next person, I'll answer some of the like questions that were described previously. So technically, for D tables to support the workflows that we just described, we need to improve the lazy loading of files, which Przemysław just described. Not only you can have lazy loaded files from the file system, but also from cloud resources. So that's one thing. Second thing is caching of managed memory to disk, which is implemented, but certainly needs more work to be more reliable. And the third thing that we need to work on is peak memory usage when using the service, because you sometimes use way more memory than it's reasonable to use with the data size that you're expecting. So I think like this is how far we need to go to support the simple use cases that you would want. Certainly not enough to replace Spark, but that's a start. Who's next?
Hello, Jarrett Revels, speaking Biosignals. Right, yeah, so I think, so we have a situation, we have a lot of tabular data sitting in S3, and I think what's interesting about having really nice Arrow support at this point in Julia is that there are a lot of kind of query engines that exist outside of the Julia ecosystem that you can kind of deploy on top of like a data lake in S3 and then use that query engine to basically like give it SQL and it spits out like a result set in Arrow format. And now like Julia can basically be like a really nice like client of those sorts of systems. And you can even like set up a distributed kind of Julia cluster and then query those systems in a pretty scalable way. And so like what's cool I think, right, is then you enter into this world where like it becomes really easy to not need to like replace those systems, but now it becomes easy to like bring your data to the compute that you have where you want to be running like Julia kernels or whatever. Like the reason that like we are interested in being able to do stuff like this is because we want to write all of our like fancy compute code in Julia. And I think at this point, like other systems like Spark and Snowflake have solved a little bit the problem of us like getting the data to those compute nodes from like you know, more static like storage. And it's I think it's primarily for us a little bit solved because of the fact that we can all read and write Arrow together, and so it even becomes a reentrant back into those systems if you had like other downstream processing that you wanted to do in Spark. I think also a lot of like bigger companies, right? Like you're probably not incentivized to try to go on a campaign to replace something that's working really well. But I think one thing that is interesting, and I don't know how relevant it is to the Julia data community, except I do think it's like a barrier to adoption for like distributed data processing in Julia, is that I think a lot of the problems that at this point Julia faces when you're trying to deploy these things in the cloud are like the kinds of problems that run into the area of like infrastructure engineering and like ops engineering in the cloud. And like I think it's a little bit of a different community than a lot of the people that are like interested in Julia. And so what you run into is like I think people that could really help us monitor monitor our clusters and make good use of probably existing infrastructure that like companies use at this point, like Kubernetes. Like those groups aren't super active here, but I could imagine a world where we provide like a Kubernetes operator or a custom resource definition for making it really easy to deploy a Julia cluster into a Kubernetes cluster, and then having that available, and then give it when our infrastructure team asks like, oh, is there a Helm chart that I can just like deploy, like giving them a good answer that's well tooled, and then getting them involved in helping to maintain it, I think actually could help push us to a world where doing things like at least monitoring peak memory usage and pre-allocating nodes and pods that have well-configured memory thresholds so that things have room to process whatever they're going to process. It's helpful if you can get those sorts of folks involved, because they're really good at doing that, I think, in other communities. Like if you look at projects like Kubeflow, right, and even projects like Ray. Like Ray has a Ray cluster Kubernetes definition and project that makes it easy for infrastructure teams to like support deploying a Ray cluster into a cloud environment really easily. So I'd love to see like that kind of thing happen for Julia. I know it's like a little bit outside the ambit of like the Julia data ecosystem in general, but.
Thanks. Hi, Timothy here, also known online as TechUsAll. If we would allow me to take a brief diversion from the distributed subtopic and go less from data D-tables more to data frames, as somebody who, hasn't been watching the space with sort of a great attention, but I think we're all aware of the arrival of Polaris on the scene. And it's been interesting seeing, well, I think at least, how the approach they have to more sort of lazy evaluation has allowed them to sort of raise the performance ceiling for certain sort of chained operations with tabular data, which obviously isn't something that's really going on with the current design of data frames. But I don't know, it's just me, I see a lot of parallels with what they're doing, and for example, the design with transducers. And so I almost wonder how realistic it might be for us to say have something where we can say pipe a data frame into a pile of data frame specific transducers to accomplish something similar to what Polaris is doing.
Any hands? Oh, your hands.
I first wanted probably to ask a question, but then what you asked is probably the question to me. But the question I have, and this is related to what Jeff asked, is how robust we are to worker failure in the whole Dagger ecosystem, and does it need improvement or not? Because what I believe is like when we start scaling things like to 100 nodes or 1,000 nodes, having some of them fail during the processing will start to be more and more important, like a daily problem. You cannot assume that everything will work. And like at least my experience with the basic way how you can, do distributed in Julia, that it's not handled well. Spark, this is one of the things that Spark actually handles. So the question is, are we there yet, or something needs to be done in order to make sure that it works? But before I give the mic, just to answer the question regarding can we do lazy evaluation and query optimization, the answer, it's a short answer, unfortunately. So data frames JL, and it's even before I started working with it, was designed to be eager. And changing it to be lazy, it's like writing everything anew mostly. So I wouldn't expect that data frames will be able to do query optimization. But we could, if this is something that really comes out as an important request, then probably like a separate project needs to be done in order to really add this functionality.
Have you ever had anybody
Because I think, could it try? I mean, it might actually already work.
Yeah, but it might work, but with query optimization, in order to make it work, actually you need to have an engine that has an understanding of the cost of operation, and this is something, so with data frames, because the point is, you can have actually two levels of this optimization. So what Polars currently does, as far as I understand, it can decide what sequence of operations is the most beneficial. So for example, if it sees that you aggregate and then filter, and then it can decide that maybe it's better first to filter and then to aggregate, because you don't have to aggregate that much. And for this, I think that, you know, with a good layer on top of data frames, if you see what sequence you have, you can do this optimization. But there is a second level of optimization where actually if you see that I have operation A and B, and I know that I could have an algorithm C that does them in one shot, instead of doing them sequentially but just optimizing the sequence, this is something that is at least currently out of scope, because you would need, like, you know, have a, this is an optimization that requires to be implemented separately, because it's like, you know, with map reduce, you can do map and reduce separately, or you can have an idea that you can do it in one step, then it will be more efficient. And this is something that is probably not possible currently with data frames. Yeah, so that's why I'm not very optimistic that in short term in data frames we can go very far there, but what you say, if we had some engine that would calculate cost of different operations, and we would be able to do like query optimization like you have them in databases, and then compose things from the primitives that data frames provide, this is probably something that could be doable. Yeah, so this is the answer to the second question, but now maybe Christian or whoever can answer my question, so this question of robustness. Okay. This was like my fear. Yeah, this robustness, because so my fear is that one thing is that we do not have to have everything that Spark has. We can have a limited functionality and target simpler use cases. I think this is fully okay. But one thing that we crucially need, I believe, is like a robustness. So if I distribute my workflow, that the workflow manager can monitor the worker, and if the worker fails, it knows what to do with it.
Okay, so
so I started looking at building I got sidetracked because I had too many other things to do, but I started looking at sort of a system for building up a stack of data frame operations. This was to put a GUI on it. And one of the key things I was doing was looking at all the data frames operations and basically, you know, coming up with a corresponding representation of this operation as just like a what did you do type of thing. And it was very much like what you're talking about. So, I mean, this would be one step in the direction of lazy evaluation, is to just sort of have a standard and shared package with those representations. Like look at the data frames API and be like, okay, well, you know, here are the types of operations you can do are filter and join and, you know, add a column and have a you know, it doesn't do anything, but a representation that tells you what you did. And then an abstract syntax essentially, and then you can kind of stack those. And then the next thing is people can, if you have a shared representation of that and you know, and maybe it's simpler a little bit than, you know, the actual operations, because some data frames operations do, you know, 3 or 4 things because it's convenient. But you could, you know, you could represent like, oh, this operation actually does these 3, 4 things. And then once you have a shared standard way of expressing that, and this is kind of like macros, right? You know, because there's a standard way to represent AST in Julia, you can have an ecosystem of code that operates on it. You could have the same thing. You could have an ecosystem of code that operates on stacks of data frame operations or table operations, and then that can become shared. And you separate out the this package does query optimizations, but if you don't care about that, you don't have to pull in those optimizations. This thing, materializes one of these stacks as eager data frame operations. This, package, materializes it as lazy data frame operations. So I think that would be a fruitful direction to go for this. I didn't get very far, but that was my thought.
So I fully agree. I will take a note of this. My only question would be the following: given, at least this is my perspective, how I see it, but maybe I'd be wrong. Given the limited bandwidth of developer effort that we can allocate to different things, really. I think we should at least short term meaning, for example, the coming year till the next conference, decide what is really the crucial thing to have. And for example, when I think about it, and if I have to weigh, whether having lazy and query optimizer is more important, or having a decent working out of core engine working, I would for sure say that I would prefer to spend 1 year on out-of-core engine, because this is a showstopper for many users to start even working with Julia. Whether this query optimizer, let's call it this way, and this abstract thing, it would improve for sure performance, but even with eager evaluation, our performance currently is maybe not as good as it could be. But I don't think it's a showstopper. It's like a thing, okay, is it 1 second or 2 seconds? And in this scope, even if it's 1 minute versus 2 minutes, I don't think someone will say, I won't use Julia because it's 1 minute versus 2 minutes. Even, sometimes we are better than other ecosystems, but even in places where we are worse, we are never order of magnitude worse. Although we could be better with this lazy stuff, etc., and optimization, which we don't do now. But if we don't have good out of core, we have a huge number of users that actually say, I just can't use it. It's not a matter if it's fast or slow. It just doesn't work for me. So while I fully agree with this stream, and I will think how to address it. At least my perspective is something what Michael said. I think he had to leave, but that having this out-of-core support, if we want to move forward and to be able to easily convince corporate users to start using Julia data stack, we need to be able to tell them what they should do if they have 1 terabyte of data they need to process. Oh yeah, you are a corporate.
Yeah, I actually think they're not mutually exclusive, right? So I think the thing that Stefan's suggesting is one path maybe to getting to a world where you have better out-of-core processing capabilities, right? So, and actually I wonder, I think actually, Stefan, what you were saying, that a couple of people have taken a stab at that in the tables ecosystem over the years. I don't know if it's ever panned out. I know there was a table operations.jl package that tried to define a bunch of primitives, and I know also data frames itself is basically providing a DSL in some sense for these things, and so I wonder, Bogomil, do you think that the data frames DSL it could be a suitable I guess IR for other things to come along? I know you designed it thinking only of eager evaluation intentionally, right? But I guess if you looked at it as and I hesitate to say this at a Julia conference, but as a compiler problem, then like, yeah, could data frames as DSL be like the IR that you like make your out of core compute engine on top of, or is that really a bad idea?
Yeah, so no, but actually I have a good answer for this, because this is something we have already tested this year, and this is something what Christian did. So probably you can say a few words what you did, and then I will add a more comment about the question is, oh, maybe I will tell you. Yeah, so the question is like, can we take what the question is, can we take the syntax of data frames and use it with another engine?
Yes, so this was an actual experiment this year. If there was an actual like D-table stock, that would be the progress from last year. I basically took select, combine, and transform from data frames as it is along the mini language that data frames has. So as you guys know, maybe some of you don't like using it. You guys use the meta packages, but the raw data frames syntax. And I added it to D-tables, which basically required me just to take the parsing part from data frames, and I got it magically working with D-tables. I would even say that there weren't a lot of issues. There are some performance nodes that you need to keep in mind because some operations, you can't just distribute them easily, so you should not do them, but it works. That's pretty much the result of the experiment. I should probably write about it somewhere, but it's already available now, so you can just take your data frames code and pretty much just change the structure to D-tables and run the same code if you only use select, combine, and transform. That's a big note.
So just to add to this, and then I will pass to you. So in general, this means that internally in data frames, we have a parser, of course, for this mini language, and this, in theory, could be decoupled if we really wanted. We didn't do this because, like, for a single package, it was easier just to have a dependency and call this parser, because this parser is pretty stable and we don't change it, that often anymore. It was, fixed around 1.0 release. So in general, we have this. But now, where is the problem? And this is something that we touched upon on Tuesday. Actually, Stefan asked about this. No, not on Tuesday. It was yesterday about this broadcasting thing. So one of the particular things that data frames JL was designed around from its very origins is that it was designed to allow any mutability you would want. So that's why we have this bank selector, colon selector, etc., because different users, if you allow for mutability, have different needs. And this is the part of the data frames API that probably will be hard to export into other packages, especially out-of-core packages, because if you are going out of core, probably allowing for fancy mutability, which data frames allows for, is not something that is going to work, as Christian commented. So this means that in general, this parser can be exported, but probably with a subset of functionality, because part of functionality is specifically designed to make it easy to work with smaller tables where you mutate things inside in a performant way.
Hi, I'm Dave Kleinschmidt, also from Beacon. I can confirm that D-tables does magically just work. It's pretty remarkable, actually. But I also, there's one major issue with using the data frames mini language as a kind of a query language IR, which is that by default, the functions you apply to columns
are not element-wise, right? So by default, you can write things that take the entire column and assume that you have the entire column as the input to the function, which makes it really hard to distribute that stuff. So, but that being said, you have this syntactic thing of the by row wrapper that's sort of like a broadcasting operator. So you could make you could use a restricted set of it as the IR, but you would have to, yeah, you'd have to restrict it a little bit, I think, to have like full compatibility with like, yeah, out-of-core stuff where you can't assume that you have the entire vector materialized for a normal Julia function to consume.
Yeah, that's actually the one part that requires attention when you try it. You should not use full column functions. I mean, functions that take a full column as input, that's a bad thing. Just don't do it. You can use it. It will execute. It will be slow. So it's just for compatibility reasons.
Yeah, but this is exactly this aspect that where in data frames we didn't have this constraint, and actually it's easy and normal, and I will just write on the table the example that was given yesterday, but probably not of you were there, where if I want to demin a column, yes, so the operation I want to do is x minus min of x. This is an operation you do every day. And data frames needs to support it in mini language because, you know, if you wanted to do by row, you would have to say, well, calculate the mean upfront and then store it in a variable and then go by row. And users wouldn't want to do this. And in data frames, it is not a constraint. It's fine to just have it as an operation. But as Christian said, what you comment, if you go out of core, of course, then the question is, how are we going to evaluate this mean of x, right?
I mean, there are ways around it where you, because of multiple dispatch, you could have a sharded vector type, right, to represent the columns that are not represented in one place, and like it's up to the user to find their own mean operation that works meaningfully on that. Excuse me. Yeah. So, yeah, still like I think so. I guess the dynamicity of Julia is like or the polymorphism is like both a blessing and a curse here, right? Because like on the one hand, we have a very simple MIDI language that is incredibly expressive and lets you do basically anything you want, right? But with very little boilerplate code. And on the other hand, it makes it a little bit tricky to like generalize. But then circling around again, because all of the functions are just normal Julia function calls, you can use all the normal Julia mechanisms for like specializing on column types and stuff when you compile it down to some kind of like out of core version of these like operations.
Yeah, so I agree with this because this is what I was also thinking, but actually I don't know, Christian, how you have now it implemented, because if you passed to mean of x some special type of vector that is like dtables specific, that is now is sharded as we have just discussed, and implemented your custom mean for this that would be efficient with respect to how you represent it, actually it would work okay. The only question is that now then you would need to have, you know, every definition for every function. So mean is probably simple, but then you go for quantile, and the question is, do we want exact quantiles, or actually we are happy enough with approximate quantiles, because with out of core calculating exact quantiles is super hard.
So I feel like that almost gets to this point where it's like if you have a limited number of reductions you're willing to define little kernels for and then like manually hook them into your query language, then you're fine. But then what you really want is some sort of mini language that lets you basically treat reductions the same way you can treat broadcasts in terms of them expressing some notion of like what's parallelizable and what's not. So like building up having some way to express custom reductions in a way that potentially composes well with like broadcast elements and allows you to reorder things. And the funny thing about that is there is a language actually that people made for doing that, and it's the language of transducers, right? So I do think that like it kind of brings us back to that, which is funny. And it's also interesting because you could say something like, well, what is the subset of the data frames mini language that actually is the one that like makes sense to support for out of course stuff? Maybe it's the language of transducers. Like maybe you like translate them one-to-one. I don't know. I do think when things get really complicated, relying on polymorphism on the values rather than constructing kind of a single cohesive self-contained language, it's easier when the language itself is simpler to do the values-based thing, but as you want to be able to do more stuff, I think you really want to have like an IR where you know how the operations compose. So anyway, my 2 cents. I'm curious about that workflow management question you asked. A while ago.
You mean building pipelines, or?
No, you started this with a question and then we totally...
Oh, so you mean the failover?
Yes.
Yeah. So probably Christian knows the state.
Yeah, so this would be a generic Dagger feature, which I think existed at some point where we had like failover and saving the state of the computation and you could restore it. I'm not sure how functional that is right now. It's technically a thing that we can do because the scheduler schedules tasks, so we can also observe if they failed. We can reschedule them if the workers failed. As far as I know, the biggest problem with that is first implementing it, and second, support from distributed JL, which is tricky. Like we have to do some hacks to to tell if a worker died, to tell if it came up. And another thing comes to mind where, on a big machine, it's pretty guaranteed that your process will spin up, at least. Like, you will get access to it. With cloud resources, you may not even see the machine or the process that you're trying to access, or it can pop up in the middle of the computation. So there's a lot of stuff. There's a lot of just quality of life things that you need to do to make it work well. But with Dagger as a base, we at least have the ability to do that in the future.
Yeah, but that's why I raised it in response to Jeff's question, because a decision, I think, is whether we need to think about support of it in just Dagger or actually in Julia distribution in the functionality that supports, distributed computing. Some things need to be added to then let Dagger more easily handle it, because maybe it's a more fundamental thing than just Dagger, but in Julia itself, we need to improve things, as you said, that to make sure what happens if worker died, or what if you tried to spin it up but failed, etc. So that's why I think this is like one area. I'm not an expert here, but probably to have a clear mind what to do, because at least my experience as a user is that if you use a standard distributed functionality in Julia and your worker dies, it's rather a problematic situation that beyond recovery. And for larger workflows, this is something that we should not have.
Thank you. So I just wanted to comment on the prioritization question earlier, and also on that in my company, what we care about the most is actually the cost of getting some job done. And the biggest part of that cost is actually people writing the code and learning how to do Spark, learning how to use Dagger, which honestly sounds amazing, and I will look into. But actually the biggest selling point right now is that, does it not work on your laptop? Fine. Take this exact same code in data frames and put it in cloud. 20 cores, 50 cores. It costs nothing. Literally, 50-core computer is $2 per hour. So you can run your data frames code. and does it not parallelize well, then this one column can be done with false.map. So you do this like surgical operation that takes you 2 minutes to change, and like you suddenly have this like column computation completely distributed, and you're done in 2 hours. You didn't have to learn anything, and everyone's happy. And that's actually one of the very frequent pitches that I use in my company to use Julia, that it just works and you can just buy a bigger machine.
I look at the watch because we have to finish before 4, because at 4 in this room another session starts. So probably since we have like less than 5 minutes to wrap up to allow people to change rooms, let me summarize. So at least my understanding is that we had 2 things that were raised as on general as the most important ones. The first is this what to do with out-of-core as a really focus for the coming year, let me say it like this, so that we make sure that we really have this deployed. We have very good progress with this, with what Christian did this year, and hopefully I know that Przemysław and Julian are working currently on this also, how to improve things in this area. But we would really welcome then, either contributions or even comments or testing what is being done, because, those things, as probably everyone knows, distributed without diverse testing won't be robust, because there are so many settings that you cannot yourself find out everything that might fail. So this is the first area for the focus of development, and the second area that was mentioned is probably a bit more specialized, and probably also will be at least initially less user visible. But this question, can we abstract out the specification of the operations and then like have it as a thing separated from a specific package, but that later could be leveraged by some optimizers or different execution engines. And this is something I've been thinking about it, but wasn't very optimistic. But on the other, not because it's not doable, but it's because it would be expensive, because like data frames was not designed against this. But since anyway with Christian we went through this way anyway to make the tables compatible with data frames, I think we can think about it a bit more. And maybe one comment why I think it's really worthwhile in long term, because it was mentioned that we have those meta packages, so data frames meta, data frame macros, and tidier. And the thing is that once we indeed reach this goal that we have this low-level language transparent and usable across different implementations, then those macro packages will just magically work with every backend. So if we have tidier, for example, and it now works on data frames, it would just automatically work on the tables, and this is something that would be really, really cool, because like you only change the execution engine, and what code you write, like what Jan said, it's like all the same. You don't change anything, but it just starts running faster if you give it more memory. And like with plots packages, we have that you just change the backend and the code is the same. At some point, probably this is something that would be doable. So this is the second thing. Yeah, probably it's mostly me or people who would want to think with me how to achieve this. And for this first objective, so this out-of-core support, here I would call for a wider like response, because I think it's really needed expertise from different fields to really get it working well, because there are very many aspects. As we started with discussion, that like Spark is a super big project with many things, and probably we need the diverse expertise to make sure that all works. And in particular, we need to work out whether we need something from base Julia to actually make it more robust when it's being started, used more widely in different environments. So this is something I would think as a wrap-up. Does someone want to say a final word before we finish? Okay.
I just wanted to say, data, there should be kind of a moment of appreciation here, because data frames is extremely boring, which is a huge compliment. I don't think about it ever. I just use it. It works. It does all the things I want. It has a pretty reasonable syntax. Just everything is just very easygoing and flows well, and I don't have to think about it. And so we should be very appreciative for you leading a lot of the data frame stuff and making actually a super good tool. The fact that we're talking about kind of crazy stuff is great. The core product is excellent here. So I think that's worth some appreciation.
Okay. So yes, so thank you very much. So with this thank you, I would also like to thank you all who found time to participate in this burst of feather. As I have said, I will try to put the notes in a more structured way and post this on data channel on Slack, and then maybe open some issues to track those things. And again, thank you very much. And we will try to organize something next year around Julia data things to give you updates and show you what we managed to do based on the feedback, like Julia does every year with the update what was done in Julia in comparison to last year. Thank you. Yeah, you're the speaker. Excellent, thank you. So I'm just moving out. I just wanted to make sure that I can. So we have two. So do we have Pete? Okay, so I have you both. So excellent. So we will be starting in half a minute. Let me just move.
Plugging things in, maybe.
Sorry?
So try plugging things in, maybe.
So that's why I'm trying to move out so that you can arrange yourself.
Cool.
To się na zakończeniu widzimy, co?
Znaczy nie wiem, no ja mam od 16:30 tę prezentację, to możesz przyjść, a możesz nie przychodzić.
Nie, no przecież ja tu prowadzić będę.
A, ty tu prowadzisz. Kurde, to ty wszystko prowadzisz. No.
Dobra, więc o 17 się widzimy na zakończenie. Okay, so Timothy has installed himself without problems. So we are starting the almost last session of current JuliaCon. There are two things left. One is at 5 p.m. We have a closing ceremony, so we need to keep our timing so that everyone makes it in time to the closing ceremony, and we can learn who won this year the Julia Community Prize. And the second thing is that everyone is welcome to hackathon tomorrow, but without not to waste too much time for the introduction. So I would like to welcome Timothy to talk about robust data management, which is kind of thing that we started to work during Birds of Feather. So the floor is yours.
All right, thank you. Hello, everybody. So two subtitles occur to me. You just get both here. I couldn't really pick one. I've got a few things I want to go over in this session. To kick off, though, let's do a little bit into the background. So I'm Timothy. You might have seen me online in a few places via the name Tekasaur. You can see the avatar over there. My background's actually in mathematics and statistics and molecular biology. I'm currently a research assistant at the Telethon Kids Institute in Perth, within a group there which is looking at computational biology. Now, I am a bit of a perpetual tinkerer. As far as I'm concerned, programming ability in many respects is dangerous, because it means that when you come across something or a situation where you go, this isn't very good, I think it might be better, I think I could do something about this, and the next thing you know, you've lost hours and hours of your life. So this is a particular project that isn't actually in the course of my work, but was motivated by frustrations that I encountered and done in my own time. Now, I had to look at a lot of data. Dealing with data in an ad hoc way is something I'm sure we're all very familiar with. It's very tempting, but it's a bit pernicious. You easily go, oh, I'll just download this file, do a few things with it, but then you get asked questions such as, where did you get this from? How do you know it's the same as this file that I've downloaded? What have you done with it? And then those can be quite difficult to answer. So I think what's really needed is a system that's reproducible, robust, reusable, in the sense that you can take, say, one data set that you've been working on in one project and transfer that over to another one. Easy to use. I mean, when don't you want that? And I think really declarative is actually an underappreciated feature. So I was starting off looking at the existing options, having a look here, and I mean, yeah, it gets more complicated from there. If you're starting looking at data, there's a whole mess of formats that you have to encounter and work with. But yeah, things do this. For example, computational pipelines tend to have some degree of data management built in. Kedro probably the standout here, but also SnakeMaker and Nextflow, but it's not really their focus. You've got some Git-based approaches, either built on Git itself or inspired by the design, as DVC is, as well as there's the Python package intake, which is a bit of a data catalog. I actually quite like it. It just doesn't quite do everything in the way that I want it to. And then there's some Julia tools. So artifacts, datasets.jl from Julia Hub, data depths, and a few others. So then I went to look and saw how many of those could I actually find that met the criteria, could be used in the way that I want them to be. And the result was crickets, nothing. So this is the start of the journey, because it occurred to me that there's actually probably a rather strong argument for a Julia native solution to data management. In particular, if you look at a lot of approaches, you sort of do your data pre-processing, cleaning, all of that separately from the analysis. By bringing that all within one Julia project, you actually can capture all of that in sort of a hermetic environment, because you've got your project and manifest.toml, thanks to how well package.jl works. Even for things like when you say, for example, calling binary files. So, for example, whether you'd be doing, say, I mean, looking at biology, something like SAM tools or some other execution like that, because we have the JLLs, that can also be managed within this environment, which, yeah, makes a rather strong argument, I think. Furthermore, if you've actually got the data sort of pre-processing in the same language that you're actually analyzing it in, I think there's some benefits you can get there. And by having it in the same language, you can now start developing deeper integrations. For example, we've got a custom REPL mode. Now, yeah, so altogether, I think this actually provides a quite compelling set of characteristics. So I think we can sort of raise the sort of high watermark in terms of the reproducibility, combination of reproducibility, flexibility, and convenience that you can actually have. So, several months later, we have datatoolkit.jl, the topic of this talk. Now, just to give a bit of an overview of this, the core idea here is that you can represent a dataset quite nicely as, with a few aspects to it. One is saying that somewhere there exists a pile of bytes, and that is what you're interested in. You need a way of actually accessing that pile of bytes. So this is going from storage to data, and that is the storage transformer. Now, just a pile of bytes by itself isn't interesting. What you really want is a structured representation of those pile of bytes, and that is the information. That's what you actually want to work with. So you have some method of going from that pile of bytes to the structured representation, and then back again, potentially. So that's your sort of loader and writer in this diagram. So this model is what I call a data set, and that's what's captured in this package. Now, this is defined actually, this is actually part of a larger model. So you've got your data sets which have loaders, storage, and writers as actually defining them. And if you have many of those form a data collection. So for example, something like a data collection, you consider like the R datasets package that has a whole collection of datasets. Now you might want to access different data collections at once. So what's actually maintained in the package is a stack. So a collection of data collections, as it were. And I think what's a bit notable here is that some of these sort of deeply nested objects in this diagram can actually access their parents, which allows for a few useful things. Okay, now this model is defined in this data toolkit base package. We've actually got not just one package, but really a sort of a trio or a sort of four in a sort. So data toolkit base provides the basic model. It provides a model, but nothing else. It's completely useless as far as actually using it in analysis is concerned. But then we have Data Toolkit Common, which does a whole bunch of things like how to actually read a CSV file, image files, and a few other things like that, and provides a number of plugins which are actually rather handy in my opinion. So if you're just doing an analysis project, we've got Data Toolkit, which is the sort of user-facing, I guess, package. You pull in that, it'll pull in Data Toolkit Common and Base, sprinkle a little bit of nice extras, and you can go ahead and start using that. If you've actually got a collection of data sets that you've put together in a package, you've actually got a Documenter extension which works with the next release of Documenter, and yeah, those are all together documented under one system. And yes, of course, you might also want to pull in those data packages into any particular analysis project you are working on. Okay, so what does this actually look like when you're using it? So we were using TOML files to have a declarative representation of each data set. So in this case, we're starting off, we're going to be looking at or using Fisher's famous iris data set. And so to start off, you just have the data set, you give it a unique identifier, and then you can give it any arbitrary metadata that you want. We define a way of actually getting that collection of bits. So in this case, we say that we can fetch it from the web, and then we have a way of actually loading that into Julia in a way that you can actually work with it. So what's notable here? We've got a named data set. It can be uniquely identified. You can give it arbitrary metadata. There's certain ways of sort of name transformers for loading the data and transforming it into a useful format. We can have things like content verification, and those methods of actually acquiring the data and transforming them into a useful representation can take some number of arguments. Okay, and then what about when you actually want to use this data set? Once you have this representation, we have this rather handy D-string macro, which will just fetch it in the form that you probably want. And so in this case, we've got data frames loaded as well, so it'll get it as that CSV as a data frame. So you can just sum the sepal lengths or something. You can actually also specify particular forms you want by actually including a type in the string. It's not eval, it's actually parsed. You might think that's a bit dodgy, but it's actually fairly capable. It gets to about 90% of the way there. For example, you can do some more complex things like actually have type variables. Now, say you've got a whole bunch of data sets, you put them together, you think that it's actually probably going to be useful for more than just you. You might want to make a data package. This is when that Documenter extension I mentioned came in. So if we expand on the iris example from earlier, we can actually generate something like this. Give information, for example, the licensing, the source, the publication it was first seen in, and what formats it's available in. And this is all just nicely generated. You might wonder how much it takes to actually produce something like this. If you use the Data Toolkit Documenter package, just add that. Use it in the make.jl file, and then just somewhere have the auto datasets. Yeah, that's it. You'll suddenly have all of the data sets in your collection documented like so. So let's see how this actually might be useful. So this is a basic way of representing data sets. Something else that you're able to do here is actually not just directly use the data set, but actually use it in producing another data set. So I guess you could call it a derived data set. And I think that this is what I found happened quite often in my usage and was where a lot of tools started becoming quite annoying. So let's say that you have a farm. You've planted a bunch of different types of crops, and you have put some different fertilizers in different fields. And you want to see which fertilizers are actually most effective. So you might start off by having, say, some tabular data giving the layout of the crops and the layout of the fertilizer that you used. You might want to put them together into, say, one table which actually has which fertilizers are used with which crops. So in this case, we've got 3 data sets here, the third one being created by using the first 2. Say then you actually get around to harvesting. You now get crop yields information. That's a new data set. You put that together, crop fertilizers and yields, you've now got it in one tabular form. You look online, you find some information on the fertilizers. That's wonderful. You might write some code to actually incorporate all of that and then, say, make some predictions as to how effective the fertilizers are. So you write a function, and then you have your best fertilizer. So what happens here is we've actually not just done each of these steps incrementally, but captured the entire relation here. What this means is, say that you realize you messed up with your fertilizer layout. You made a mistake there, you correct it. Without doing anything else other than just changing the data that you're using in that fertilizer layout, the change there will just propagate right on through on demand. And so if you combine this with, for example, storage caching or computation caching, this will mean that you just recompute things when needed. Okay, so all of this happens via what I call transformers. So if you go back to that graph from earlier, they're the storage, loader, and writer bits here. The ways of going from a pile of bits to acquiring a pile of bits and going between bits and actually structured information. Implementing them is, in my opinion, dead easy. We have functions for each of them, loaders, writers, and storage, and simply by implementing those functions, they become available to use. So let's actually get some examples. Say that in this TOML file, you just have a value key. All you need to do is say, I'm fetching the value from that. This is just a little macro that's just for convenience. Okay, so this isn't just a toy example, this is the actual implementation we have in Data Toolkit Common. Okay, how about JSON then? Well, we've got JSON 3, so we use that and we just read from the source. Once again, this isn't just a toy example, this is the actual implementation. And then you get the idea, writing to JSON, we might want to check the pretty parameter, so it's a little bit more complicated, but for the most part, simple things are simple to implement. Right. At the moment, we have 23 loaders, 18 writers, and 6 storage backends. They cover a range of things from images to compression to tabular formats. This is basically just what I found useful. I hope to see other people actually come along with their own loaders for their own data formats that they have to work with. Okay, that's a quick run through the one major component of the system, which is transformers. How you can actually acquire the structured representation of the data that you want using a system which actually allows for declarative representation of your data sets with all sorts of niceties. Now, many of those niceties are actually available via plugins. So there's I think we might call a somewhat sophisticated plugin system here. Why? Okay, a few things. One, I think it's important to allow opting into certain functionality. I don't just want a massive, here's the kitchen sink type approach. Another concern I have here is that certain functionality there might be a bit contentious. There might be different ways you might want to go about one thing. And so I wanted to avoid privileging just one particular approach by baking it into the base package. Finally, I want this system to work for use cases that I have currently not even considered, which are far beyond what I've envisioned. And so for that, I want something which is flexible enough to accommodate beyond what I've currently thought of. Now, you might think, say, a simple plugin system. You've got, say, 1 or 2 well-defined spots where you can plug in to the existing code base and, say, do this first. Just say a list of functions, something like a hook-like approach. I think this is a reasonable expectation. What I've actually found has happened here is that we have a bit of a mess. So each of these circles basically represents a function call where you might want to do something different. Sometimes multiple plugins might want to affect the same function call. A function call of a particular type might be scattered across different parts of the code base. Simply put, it's a bit more complex than actually considering. I have found, I think, the plugin system we want, I think there are quite high demands here, ideally. So modification of multiple places, I've already mentioned. We've also got arbitrary code we want to be executed before and after the function call. Change the arguments of the function and possibly the return value as well. And then I actually want to also be able to prevent or change the function being called. Okay, those are mostly achievable, but then we've got 2 more. I also want this to compose with other modifications and actually also be applied on a per data collection basis, not actually be global. How is this actually done? Well, I think one approach which actually works rather well with this is called aspect-oriented programming. So if you're unfamiliar with this, as I was until I discovered I accidentally implemented it, there are a few terms here: aspects, join points, point cuts, and advice. So, put simply, advice are simply modifications that you want to make at a certain point in the code base. Join points are locations the locations in the code base you might want to modify. And point cuts are ways of identifying this advice, these modifications apply to these locations in the code base. So you can have one bit advice that actually applies in multiple places, and you can have multiple advice that apply in one location. Now, how does this actually work? You can sort of think of an advised function call as sort of this function up there. Now, the extra thing that we've got here is actually composable. So if you have multiple advice applying, you basically run through all of the pre-processing steps, so modifying the function and its arguments, take the result, and then run that backwards through all the post-processing steps. Another way that you can think of this is actually having shells of advice built around each other. How does this actually look like in practice? Well, say that when writing to the file system, you actually wanted to create a git commit every time that you've overwritten the file. So this is a good use case for plugins. What we can do here is say that when we see a write function being called with a file system data writer, and it's written to some path with some information, we define a write commit function, which with the result will actually it'll just pass the result unmodified, but before doing so, we run git reset, git add, and git commit. So we just pass that through in the sort of result tuple, and that will be executed afterwards wherever in the code base that you have these special calls of write. What have these plugins been used for? Okay, so far we have 6 plugins. We have a plugin for actually supporting default values, a plugin for convenient syntax of specifying certain versions of datasets, for actually caching to disk an I/O source, as well as a cache plugin for actually caching the Julia representation. Memorizing, so keeping a Julia representation of a data set alive in memory after accessing it the first time, and then as well one for logging. So this is an example of some of the things that have, or at this point, already been done with plugins. Okay, so if time allows, we have a live demo, and I think we do just about have enough time. So, if I pull up a Julia REPL and try to hold the microphone and use the keyboard at the same time, which is a challenge I had not anticipated, I must admit, we'll run Julia 1.10 because it's a bit quicker to load things, and use the data toolkit package. So what happens here is we can actually, I'm actually going to demonstrate the data REPL and the sort of ease of use part, which I mentioned right back at the start of the presentation. So by typing a closing curly brace, we can enter the data REPL, and let's find some data set that we want to look at. So let's say iris, for example. So I think somewhere Seaborn iris, let's see, CSV, we should find a result here. Okay, yeah, here's a lovely iris CSV. So if we just grab the link to the raw file, let's copy that, and say we want to use this. So add iris, and here's the path. Oh, but we actually haven't initialized a data collection. So that's easy enough, we just do init. There we go. Do we want to create a data.toml file for the current project? Yes, we do. Call it live demo, that sounds good. And there we go. So at this point, we can just rerun the existing line. Let's see, Fisher's data. That should work. And then we're done, once it's actually run the things. So at this point, all we need to do to use it is just go iris, and we can access that data. Once it's actually running. So it needs to download the file, of course, and then, we actually need to parse the CSV. So this has a system basically that's the reverse of package extensions. Instead of actually loading code when after loading a certain package, you actually want a certain package when you're using certain functionality. So in this case, we just try to look at the CSV. It's gone, yes, this is a CSV, and it's recognized that, but we don't actually have any packages in this project that can do it. So ask if we want CSV, and yes, we do. So I'll just have to quickly fetch this, and wait for pre-compilation, after which it should just spit out the iris data file. And lovely. Yeah, so this system works rather generally. It's got a few sort of heuristics when you say, I want to add a certain resource, and it would just, all this really does is just generates that data.toml section. So you can accomplish the equivalent result just by going into the data.toml file and typing it out, but I think it's important that with a system that's, I think, got a few of these advantages, like being declarative and having a few sort of guarantees, for example, like checksums for robustness, that you can also be easy to use. And I don't think this is a situation where you have to compromise. I think this, with a bit of extra work, you can actually have both at once. And so the REPL mode here is really for that. It's for the convenience. Okay, it looks like we've now got CSV, And so, yeah, there we go. If you already had the package in the project, you'd see this much faster. And yeah, at this point, we can have a look and do other things, for example, like list the data set. And then there we go, Fisher's iris data. If we had a few other projects, we'd be able to look at the actual data stack, but let's see. Yeah, at the moment, we've just got the live demo you see, which is using the store defaults memorize plugins. And then if we were to, for instance, actually want to look at some of the information, for example, about the plugins or the loaders, that is also accessible within the REPL. We've got, at this point, a fair few sort of handy commands implemented. For things like searching from datasets to creating derived datasets. Yeah, there's conveniences for all of these. All right, so let's go back to the presentation. That's just a taster. Yep.
When you do the iris string, if it's already been loaded, it caches that, I assume.
Oh yeah, so I can just go back here and just go up to iris, and let's see, there we go. So yeah, once it's loaded, it's there. Also saved to a disk. We actually, use the store plugin actually means that if I now disconnect from the Wi-Fi and try to, even in another project, reload this, because it's the same recipe for the iris, it's the same path, the same checksum, or if you actually tell it what the checksum is, it will actually recognize, no, I actually already got this file. It maintains a cache based on all of the data sets or all of the I/O that you actually want to source, and then garbage collects that as they're no longer used. So yes, that's a sort of deduplication method, I guess you could sort of characterize it as. But yeah, just to finish off this actual talk, I've got some plans at this point. Test, some more tests. So at this point, the base model itself, I think, is actually about 85, 90% test coverage. But Data Toolkit base itself is, I think, with these sort of extra functions on top of that, only about half covered. And a lot of work needs to be done with Data Toolkit Common and, well, actually, really just Data Toolkit Common. Documentation, there's a bunch that already exists, but it's a work in progress. I think I've, at this point, got the sort of bare bones of the user-facing documentation. We've got a tutorial up, but a lot more needs to be done for the actual internals and the other packages like Data Toolkit base. Transformers, as you already saw, a bunch exist. Using package artifacts with this seems like a nice thing as a sort of why not. And I think at this point, S3 and GCP are glaring holes, just not things that I've personally used myself. Okay, and then lastly, as mentioned earlier, actually being able to export particular data sets. So if you've got a project where you have, say, I don't know, 20 data sets, you go, I want these 3 in another project, just to have a convenience to take them and everything needed for them to work out into a file. In a related note, I think actually a self-contained combination, data.toml, project.toml, manifest.toml. Basically, this is all of the data that I'm using, and everything needed to reproduce it in one file. Seems like a nice idea. Haven't explored it yet. Okay, so if this sounded interesting to you, I think I'd love it if you actually have a look at the tutorial, try it out, see if this actually works well for you. We've got the work in progress docs for everything. This is the unified docs mentioned earlier. I think they're fairly easy, so if there's storage and data drivers that you want and you can't see them, please just give them a shot and give me a shout if there's something that isn't documented or you've just got other questions. And lastly, I'm very keen to know what you like or dislike about this system. All right, thank you. All right, we've got one microphone to share.
I just want to pass around the mic, so we have, I think, 3 questions, and it's about enough of 4, so.
Yeah. Sorry if I missed this at the beginning. I walked in a little late, but in terms of local storage, are there options to decide like exactly where on the file system that you're going to store everything? Because most of my data sets are way too big to have on the main drive.
The web storage driver that you can just, you don't need to download the file, you can just stream the I/O, and possibly I can just provide an I/O stream to whatever. The store plugin that I mentioned, just because I like it, you can dump that to your disk somewhere, and you can set where exactly that is.
I think we should have him have the mic and repeat the question. It's not going to be able to.
Yeah, but Alfie, do you want to add something more? Or? Yeah, okay. No.
Give the microphone, sorry, it's going to read the question.
You will repeat the question. Ah, okay.
And I hope you'll get the question and the answer.
Yeah, sure.
Then I'll just shout now. So thank you very much. That was really cool. I'm excited to start using it, and I think you may have just for my PhD, I have to write a data management plan. I think you've just kind of done that for me. A question I had was, so currently I use artifacts to store anything I generate as part of the package that I build or that I download first and then use as part of the package. Do you envision this package to kind of replace all of that?
It can sort of work with it. So particularly with, I mentioned like an artifact storage backend is something that I see very much working with this. Sorry, the question was, I think, about how this plays with the current use of artifacts, more or less. Yeah. There are other aspects to this. For example, you can actually define multiple storage loaders or just use the first one that actually works. It does a sort of pairing process between the loading and the storage. And so what you could do is, for example, if you actually go through, say particularly in the case of a derived data set, where you actually need to do a number of steps to get to the end result, say they're even computationally intensive, and so you don't want everybody to have to do that who just wants to use the data. What you can actually do is you can take that result, shove it, say, somewhere online, put it in an artifact if it's less than 2 gigabytes, and then actually add that as the first storage backend. And so in that case, you've got simultaneously just grab it from the artifacts location, easy to use, you don't need to do the whole computation yourself. And then, I don't know, if the artifact server explodes or if you just want to have extra information about it, you also have the full information needed to reproduce the result. Yeah.
My question is your package capable of supporting binary formats like, I don't know.
Like images?
Could be, or maybe just seismic imaging or something like a binary array that is saved in a binary format. It's not a text readable file, right?
Okay, so the question is about support for binary formats as well as textual formats, which makes sense because what I demoed was just a CSV, which is purely textual. Okay, so this isn't really specialized around any type of format. All we say is that there's a pile of bytes somewhere and you want to do something with it. So, for instance, images, which are of course binary formats for the most part, are already supported. And all we do there is we just say, here's a pile of bytes, and then this pile of bytes is an image. That is the loader, just saying this pile of bytes is an image. And so we just pass this, I think, to the appropriate images.jl package to actually get the associated metadata, and so into the appropriate form that you can actually work with it. So I don't really know the details regarding, say, seismic imagery, but on the face of it, I don't see any issues that would pop up. Yep.
So a common task is like that you load the data set into a bunch of transformation and then eventually the data becomes something that's completely different than the original data set. So I understand that you understand this problem, but like I don't understand how your package deals with this, like with the, so when you transform data, like does it record automatically what you're doing? And then apart from that, like let's say somebody changed the data set outside of Julia, and then when they load the data, does the package check the hash to make sure that it's actual the data that it expects? And then if it doesn't, does it suggest that we create a new version?
Okay, so the question was about how to actually capture what's done to a dataset to create a sort of derived dataset, as I've been calling them, and also how I can be sure of the integrity, say, if, say, a file on the disk is actually modified outside of Julia. I think that's basically it. Yeah, okay, so I think it was worth me quickly jumping back to the earlier sort of example diagram I had. Oh, there's quite a few slides. Here we go. So in this case, every box here represents a data set except for the run analysis. So this is a function, and the expectation here is that this would be a pure anonymous function where it transforms the various inputs into your result, and that would be either included raw in the data.toml or in some file somewhere. And so there's a Julia loader that's been implemented, which just goes, okay, I'll just load this anonymous function, run the various inputs through it, and then the result of that function is the loaded form of that data set. And so that's captured within the overall data.toml file. And yeah, which allows that to be just automatically reproduced, for example. So if you had none of the actual computations done here, and you just say, I want the end result, go, okay, to load that, I need to run this function, and then I need these inputs, and sort of recursively fetch what's required. Say if a file was edited outside of Julia, that depends on the various checks that are in place for file integrity. So in this case, the way that we check file integrity is either checksum if it's available or the modification time of a file. And this is just with a particular implementation of the file system loader. You could write your own one that took a different approach to this. But that means that if a file is modified, either its checksum will change or the M time will change, depending on whether you chose to track that. And so then that would show up as a changed file. And the way that this best fertilized at the end knows that it doesn't need to recompute anything is because it basically does this sort of Merkle tree style hashing on all of its dependencies. So any change anywhere in the sort of DAG that it requires will change the hash, and then it'll go, okay, I need to recompute things, which should ensure that your results are actually up to date with any changes. Feel free to come to me afterwards. I've been basically just tinkering away at this to try to get it into a shape which I think is fit to have other people try it. So yes, I'm very keen to hear thoughts on the overall system or any of the specifics. Thank you. Yep, I get it. Yep.
So I would like to invite our last speaker, Piet van der Pit, who will talk about kind of similar things because data persistence architecture for JuliaSim. So let us give a few minutes for the speaker to get installed, and we will start, and we try to finish 5 to 5 to let everyone transfer to the main. To the main room. Okay, so the floor is yours.
Yes, thank you very much. I will put this mic here. So good afternoon, everybody. My name is Piet van der Palt. I work at the Royal Military Academy in Belgium. And this technology that I am going to present is the result of the work that we did there in collaboration with the Vrije Universiteit Brussel. So the title of today's presentation is Data Persistence Architecture for the SimJulia framework. So we need to make the clear distinction between JuliaSim and SimJulia. This is completely a different package than JuliaSim. Okay. The content for today's presentation. First of all, I will start with the goals of our research. I will talk a bit about object relational mapping because that is key to the understanding of what we have been doing. Then I will elaborate a bit more on the technical context of any simulation and more in detail about model expression, simulation, and output data, because these are the three main aspects where we did a contribution. I'll come to the conclusions and I'll present you the future prospects. So the goals are the following. First of all, we want to realize a web-based architecture for modeling, simulation, and visualization in support of research and education simulation requirements. And furthermore, we want to remove the dependency on a user's knowledge on architectures for persistence. So the current state of the SimJulia package is that the user is responsible himself from within the code to do everything that has to do with persistence himself. And because we want to direct the package to domain experts, but not necessarily programmers, we want to get rid of this dependency. It has to happen for him without any intervention. What are the involved technologies? So we have the SimJulia package, which was written at the Royal Military Academy by Ben Lowens, and which is now migrated to Concurrent Sim, which will be a part of the Julia Dynamics team. We have the resumable functions.gl, and both of these packages are actually the main packages related to simulation. Then we have the Postgres ORM package, which is a package that we use for persistence, and the Vue.js.gl package and the HTTP.gl package for the visualization. And then apart from the Julia technology, we have the PostgreSQL database management system, which is our database, and Node.js, Vue, and Vue CRUD, which are the technologies we use for the visualization. So having said that, let's continue with the object relational mapping. So what is an ORM? An ORM implementation consists of a language for mapping between the object and relational domains and an API for storing, querying, and modifying application objects. Now, in our case, I told you before, the Postgres ORM.gl package by Vincent Laurier is very important to us because that is really the core of what we are going to do. So what is the ORM? First of all, we have the mapping aspect. At the left-hand side, you can see a mutable struct that is defined. And it is a bit odd the way it is defined because of the type definitions of the fields. We always have the union of the missing and also the real type that it can take. So an object that is instantiated this way I must not have all the attributes present. So this is really very particular to this implementation of Postgres ORM. And then at the relational side, it maps to some relation with the same attributes. So what is really the information that is important here? That is the layout of the object and also the layout of the table and the mapping between those two. So this is the configuration that is important to us. And once the application starts to live, we are going to instantiate these objects and we are going to use the API to perform CRUD operations. Okay, now where does this come from? The guy that implemented this, he makes an example of a web application and a database backend. So really, with us, we are going to replace the web application with a probing approach of a running simulation. Okay, after this comes the technical context with the three main aspects that I'm going to discuss. Any simulation has a model expression phase, a simulation, and output data which is generated. So model expression is always the translation of some real world, and in our case, discrete event process, which is translated into something the computer understands. It's a specific language which is used for that and specific packages involved. Now, in our case, we will use Julia programming language, of course, and we will use the package resumable functions. Once this is done, simulation will run. The simulation will run on a certain simulation technology, and this is then the SimJulia, concurrent sim now. And then, while the simulation runs, we will generate output data, and we will analyze that data, and we decide upon this as a consequence of this analysis. Now, what are the required tasks to analyze this data? We need to collect it, store it, and we need to exploit it. So let's now take a look more in detail on these three phases. First of all, the model expression. So we start again from this real-world discrete event process, and we're going to translate it in a simulation model. Now, what are the specifics of this resumable function package, and what are the contributions that we made? First of all, at the macro expansion step, prior to the compilation, this is really when the simulation model is being made. In fact, we are going to express the process as a function, and the resumable functions package will translate this function into a finite state machine instance. And this will all happen by means of macros. So in the default implementation, furthermore, nothing happens. It's merely that automaton that is made. And what is now our contribution? Well, we use this phase to retrieve the configuration of all the state variables that live in that finite state machine. And we do this while keeping track versions of the same FSMI. So what do I mean by that? You can have some kind of simulation model which is expressed as functions. You are going to save the configuration of the simulation model. You run it, you see that something is not okay, you will change it. This will lead to another set of configuration. And then you will maybe revert back to it. Then you will fall back to the existing configuration. So that is the versioning aspect. Now, how does this look like a bit more tangible? We see there the @resumable macro, and the @resumable macro takes a function which has a while loop in it, and we are going to pass three steps, the green, the blue, and the orange. And then the second argument which is passed to the @resumable macro is a persistence flag. So this persistence flag was our contribution. We are going to tell to the system, yes or no, persist this model in the database. And at the finite state machine interface, you see what it looks like. You have a starting position, you go into the states A, B, C, and after C, you return to A. So this is really the FSMI. Now, how are we going to store this configuration of the state variables of this automaton? Next slide demonstrates this. So the model expression defines the variables, or slots, as called in the terminology of the package, to be stored during the simulation. And we are going to extract the configuration, and the configuration is really defined by 5 parameters, being the name of the function, the field name of the attribute that you are going to store, the data type it has in Julia, the name it's going to have in the relation, called their ORM, and whether or not it participates in the relational side as a primary key. So this is really a static ORM. Here we used the package Postgres ORM as it's intended to be used. Now, it is this information that we will use later on to create the dynamic ORM, and I will come back to that. So this was really the first part, the model expression. Now we come to the second phase, the simulation runs. We have a simulation model, SimJulia runs it, and while it is running, we are going to probe the simulation. So the simulation model runs as I expressed as FSMIs, but prior to the simulation, there is something really important that happened. There's a very important macro expansion that took place, and this is the dynamic ORM. And it is based on a per FSMI probe definition. What do I mean by that? If you look at the diagram, you have the configuration partition in my relation. And there lives all these data that I extracted concerning the state variables in the step prior to running the simulation. So this dynamic ORM is created and is available to the simulation probe. So what happens now, in SimJulia, while the events are being called, every time we have an event that is being called, it is being probed, the finite state machine is being probed for all the state variables that are present at that moment. They all are saved by means of an object that is instantiated, and they are passed to the database. So that's really the conceptual how it works. Now, a bit more in detail again, in reality, when you do it, how does it work? At the left-hand side, you see running the simulation. We have add process, the name, and then the argument of that function is a simulation environment. This is nesting the main process of my discrete event process in the global scope. And then I start my simulation. So what happens? The first event is being called, and immediately after the event is passed, an array of callback functions is being invoked. And what did we change? Well, either way, the last function of this array is now the probing function. And as an argument, it has that finite state machine. So we have the complete state of this finite state machine available to us, and we can persist its state. And this is really how the probing aspect works. And let's look a bit more in detail now how the probe will select the correct instantiator of an object. Again, at the right-hand side of this slide, we have that configuration. And in blue, you see the object class definition and the ORM class definition. The blue ones are the static ORMs, and they are passed to a macro, which will generate, first of all, the layout of the objects that we will need to store the state of all the finite state machines that live in our simulation, but also the way they will be persisted in the relational database. So with this together, I have really now a dynamic thing that is now available to my probing initiative. And let's look at the left-hand side now. We have the simulation. We have an instance of a finite state machine. And we have all of these constructors available. Now, the question that we need to answer is, for that FSMI, which constructor will we use? We will find it, and a shadow object will get instantiated. And it really depends on which process that has been translated into a finite state machine that is under consideration that will determine the constructor that you will use. At a certain moment, this object is instantiated. I'm at the lower part of the schema now. And we will use that dynamically created ORM configuration to save, to persist the data in the data partition. And at that moment, we really have the data available. It can be seen, you can put it all together in this detailed architecture that I present to you now. So at the left, you see the simulation. At the right, you see the persistence. And we implemented the complete layer between these two. In blue, again, the static part. So we do code analysis on the simulation model to extract really configuration of the state variables. We persist that in the database. And then we go from the configuration the upper band to the lower band to the data partition. There is macro expansion that takes place, and I have all my instantiators available to my probe. So at this moment, I can persist the data using the API, but the API is being fed dynamically. So now I have the data in my data partition. The third part is about actually exploiting this output data. And so again, what do we have? We have a data interface somewhere, and we have that dynamic ORM again available to us. And we want to retrieve data objects now and present them to a user. Now, how can we do this? We do this per FSMI. It is dynamically and config-based. By this, I mean the simulation took place at this moment, or at least one iteration of the simulation took place. So per FSMI, I have a relation available, and now I need to retrieve the data in that relation using the same ORM. And I can do that because, again, because I have all the configuration already available, I can create an object, which will now be a filter object, to retrieve a data set. And I can do this per step. Per step, I mean the full content, the full table content is available. So what is the process that takes place? The user requests the data at the data interface. The appropriate retrieval object is instantiated. It's a filter object now. And that filter object, which can, for example, have all of its attributes to missing, is used to retrieve the data from the database. This actually maps completely to a select star from without the where clause being present. Once you have sent this filter object to the database, the data is offered at the interface. And then we have two approaches. We have a direct visualization. This is intended for a user who is establishing a simulation to present him immediately with the possibility to view the data. And we also have an application-oriented implementation where we have created a REST interface which can be completed with an architecture of choice. And we choose to implement a Node.js implementation together with VueCrud, which is really a package which you can deploy, or you can write your own in Vue, and that is something that we did also. Again, here is a schema that explains it a bit more in detail. So again, there is a lot on the schema that you already saw. We are going to extract from the configuration partition the configuration of how we should create this object. Macro expansion takes place. I have my constructors available, and then I go to the right-hand side of the slide, and I have my user who is present at my data interface. He requests a resource. Now, how does he choose amongst the resources available? Well, simple. He has a list of all the constructors available. There is an empty object which gets created, which is sent to the database, and the user is presented with the data he requested, either through a HTML page that we provide to him by means of Vue.js.gl, or we show him the JSON file by means of the REST interface. Okay, now how does this look like in reality? Here I show you the direct data visualization. So we have some URL which a user can browse to, and there he is presented with a list amongst which he can choose, and when he chooses one, he will be redirected to the next interface, and this will provide him with an HTML table which has all the state variables of a certain simulation available. So in this case, I present you the result of a car waiting for a traffic light, and simply all the time the traffic light wait time is always set to seven units here. So that is really nothing special, but it's to show you that we can showing the data. Now, this allows for fast data exploration. The alternative approach was the REST-compliant data interface. So we have the data accessible at the URL that you see there. And we have the JSON format which is fed into, which can be fed into the variety of applications. And as a proof of concept implementation, we used the VueCrud the VueCrud package, which is designated as a Vue.js-based RESTful CRUD system. So this took it took some configuration effort, but we were able to make it work together with our REST API. And as an alternative to this, you can also choose to generate, not to use a configurable package, but then you will have to write your application your own. And that is what we did here. So, in conclusion, what did we do? We created a transparent data persistence and exploitation for SimJulia. We have a user-friendly designation of monitored processes, simply by providing, in the first step where you do model expression, a true-false flag at the macro. We have a data model which is dynamically defined by the simulation model itself. So it's really, all the stuff happens behind the scenes. The user has absolutely no task in configuring how the storage should be addressed. It just happens for him. We have the model metadata, which is kept for each version of a process. So throughout the development of a simulation model, you can go back and forth between existing and new versions. That will have no effect if you already created a prior version of a certain process. And we have persistence, which is realized automatically by the simulation software. And then after you have run your simulations or during, your data is immediately available through the web interface or through the REST API. And the REST API opens possibilities to use other data visualization approaches. And we used ViewCrud together with Node.js or Vue on its own. What are the future prospects? So this is actually two parts of a threefold. We have the simulation and we have the visualization aspect. We want to complete this with a web interface where we can do the same model expression as we do today in our integrated development environment. And this would be great for teaching simulations to students. What we also want to do is fine-grained probing. Currently, we will save all of the finite state machines variables, and we want to exclude. We want to at least have the possibility to exclude some of the variables. What we also noticed that because of going back and forth to the database, we have an enormous loss in performance, and that is something that we need to address also. Okay, you will always have some loss in performance, but there some significant gains are still possible. So this was the end of my presentation. I thank you very much for your attention, and should there be any questions, I will answer them gratefully now.
I have a comment actually, because I am doing a lot of simulations, and I actually expected this last bullet. I can tell you what we typically do to improve performance. So you spawn two workers, like in two threads. One is running the simulation. The other is only responsible for writing data to the database. And you don't write it immediately, but you pass from one worker to another in memory, the data that is collected, and the second worker saves the data to the database in batches, but it does not slow down the simulation. Of course, you need to make sure, for example, that you have enough memory, but saving data in batches, first of all, makes less transaction to the database and each transaction is costly. And the second thing that maybe even it's enough for you that you have some delay in saving the data, but you can finish the simulation quicker. So in general, my experience is that batching, writing to the storage of the data should improve things, and as a higher level, you can even have this writer process as a separate task or thread in Julia, so that in the first thread you can normally run the simulation, and the second thread just collects the data and makes sure that it's written correctly.
Super, that's a great hint. Thank you very much.
Yeah, okay. Any other comments or questions? Yeah.
Can you use a different modeling system than SimJulia? So how connected is your ORM processes with your simulation processes? Could you use agents.jl, for instance, or even an optimization model?
No, they are really very, very tied together. So it's really an extension. So the work that we did on resumable functions is now going to be incorporated in the package, at least that is the goal. And then for the ORM, it's also something that we are going to integrate really in SimJulia. Concurrent Sim is the name in the future that we will use. So it's all very tied together.
You're not the author of Postgres ORM, are you?
No. That was Vincent Laugier. So everything we did is we simply put together all of the components and we made them work together.
Thank you very much. If someone has more questions, just please contact directly. And now I invite everyone for the closing ceremony. So again, thank you very much.
Thank you. I don't have a business call.
No. Okay, if not, it's not a problem. I will ask one person from my team to contact you because we will definitely use what you do. It's excellent.
Thank
and
you.
this comment about performance is minor for teaching. It's